Welcome everybody and thanks for joining this course, Mathematics for Computer Science. Now in this course you will learn the following. Foremost, you will learn what a definition is, and then what exactly do you mean by the term proof. You will learn about sets. You will learn about functions. You will learn about relations, and you will learn about discrete structures. You will learn about modular arithmetic. Some books spell it as arithmetic, some of them they spell it as arithmetic. So I'm including both the spellings. You will also study about graphs and state machines. You will study about counting. You will study about discrete probability theory. So all of these things would comprise a full-fledged course for mathematics for computer science. And having mentioned that, if someone were to ask you, have you studied discrete mathematics? Then your answer should be yes, because the moment we start here, we are actually going into the field of discrete mathematics. So all of these from the start towards the end is considered as the area of discrete mathematics, the field of discrete mathematics, and it's really a huge field, and this course is done very extensively. So the first part of the lecture, I will define the term definition. I will explain to you the term proof, sets, and I will give illustrations of the different types of sets, the different types of operations that are performed on sets, the algebra involved in sets. So that will be the first lecture. In the second lecture will be on functions. The third lecture will be on relations. Fourth lecture will be on discrete structures. The fifth one will be on modular arithmetic and graphs. And then I will start off with state machines, and the next lecture will be on counting, and then discrete probability theory to end with. So this is a full-fledged course, and if you know this course, you are simply powerful, and that is to say the least. Okay, so let us start off. Before I could start off, let me explain to you what is discrete maths. You can either say it as discrete mathematics or you can say it as discrete maths. Now, mathematics, you will have to know mathematics is the single most powerful field which is found in all areas of science, technology, social sciences, real life concepts and principles. You can name anything you want. You will have mathematics at least to some level. And that is the way it is. There is no questions asked with regard to why should we study mathematics. Most of the times computer science, or I would say software engineers, software engineering, right? People who are studying computer science and software engineering, they have a disdain towards mathematics. Apparently, few sets of people who are pursuing the course either through the university or through independent study or through third-party institutes, they are very much focused on learning programming languages. Now, programming languages, as you all know, they are categorized into different areas. Say, for example, you want to be a web stack developer or full stack developer, you will learn languages like HTML, CSS, and JavaScript. On the other end, people might go on to learn application development softwares like Python, C++, C, and let us not take C into account because C is more like a technical language. But of course, with Python and C++ or even Java, people always think that they do not need mathematics. They can just do away. Say, for example, in case of HTML, CSS, and JavaScript, they might think that, okay, it's okay that we don't need high level of mathematics, or we do not need mathematics. All we are doing is website designs. Okay, website designs, well, using CSS and HTML, you will be able to do certain things, certain basic things. Even designing a page using CSS, when CSS comes into action, you will have to have at least the understanding of coordinates, basic coordinates, because CSS has got the ability to do animations. But when it comes to designing application using JavaScript, you will have to have a greater level of mathematics. That is obvious. And this is not to say, if you do not have higher knowledge of discrete mathematics, you will not be able to design any applications for that matter. When I say applications, you need to utilize creativity. When you talk about creativity, efficiency also comes into place, and that would mean you need to have a powerful algo. When I say algo, it means algorithm, to form the base. So how do they actually create an application? They create an application from the algorithms, and this algorithms will definitely include space and time complexities. Anyone would be able to implement it or even design it or execute it should have a powerful understanding of discrete mathematics. This is just to give you a brief understanding why you should have a mathematical thinking and why you should know discrete mathematics. Okay, coming back to the concept of mathematics, this area considered as the lifeline. Now this lifeline has got two major branches. Now one is called as continuous math, and the other is called as discrete maths. Discrete math. Now, where do you see continuous maths? Say, for example, you are counting, say, $1 to $10,000. How would you count? You start with the first dollar, move to the second dollar, third dollar, the fourth dollar, and so on up until you reach $10,000. Right? So that is continuity. After 1, you follow 2. It doesn't matter even if you're going to count between 1 to 2. So there are huge numbers that are being present between 1 to 2, and their count have to be continuous. Say you're starting from 1 and you want to reach 2. After 1, what is the next number? So you're looking for the next number all the time, and that is continuity. And this is applicable. Say, for example, you are standing in line to get tickets for a movie. Say a new cinema has come out and you're standing in line. The ticket will be given to the first person. The ticket would not start, or the ticket giver, the person who is giving the ticket, he will not start from the fourth person and share out the tickets. No, that's not going to happen. So they will start from the first person, they'll reach up to the last person. So that is continuous maths. Now discrete maths, imagine you have a textbook, right? This textbook has got 1000 pages, 1000 pages. And you have somewhere read in between this textbook a formula, and say imagine an integral formula a to b root of ax squared positive bx positive c times dx. There is a formula given to integrate an integrand of this fashion, and you remember that you have found this particular formula somewhere between 565 and 595 pages, right? Page number 565 to 595. My question is, would you flip the page starting from page 1 up until 565? Would you start doing it to locate this formula? No, obviously we would not approach this action in this fashion. Immediately we will open the book, approximately say 500 or 540. The moment we open the book, definitely we know, right? So that is the understanding of discrete math. We don't progress sequentially. That sequential progression is totally avoided. Why? Because we need to save time. We need to save time. In other words, discrete maths is used in computer science in a great fashion. Why? Because it saves time. So if I were to ask you what is the use of discrete maths in computer science? I would expect you to give me this answer. Discrete maths provides an essential foundation for virtually every area of computer science. This is the mere basics of discrete mathematics. In other words, the discrete mathematics area is so large. Any area you take in computer science, the application of discrete mathematics would be hugely found. It will be mammoth. So having mentioned that, let us go on to the first thing, the first terminology which I just said. So this is to give you an understanding what discrete mathematics is and what exactly it can do. The next one is, let us start with this terminology, definition. Now you might be looking for this term whenever you begin to design an application. This definition is a very important terminology. I have two statements, statement 1 and statement 2. He is a lawyer. She is a housewife. Right? Two statements are given. Now, he is a lawyer. So what is the meaning of this? Can you tell me? What does it really convey? It conveys that this gentleman is a lawyer. Simple as that. Now, to be a lawyer, this gentleman has to fulfill a list of requirements. So that requirements would be present there to define a lawyer. Have that in mind. So if you want the definition of a lawyer, the lawyer will have to fulfill the list of requirements. So that is the point that you will have to know. Similarly, this young lady has to fulfill the list of requirements that defines a housewife. That is the simplest way to get a grip of this term. Now let me go on to the major term, proof. Now, what is a proof? Let me give you the statement. Proof is a method to ascertain, A-S-C-E-R-T-A-I-N, to ascertain the truth. So, you might be asking me, what is the meaning of ascertain? Ascertain is nothing but, when I say ascertain, it means establishing or verifying. Say, I started with this example. He is a lawyer. Now, how would you ascertain? So, in fact, this is a proposition. He is a lawyer is a proposition. Now, I've just used a new terminology, proposition. Now, we need to know what is this term called proposition. So, let me come to that term now. So, what is a proposition? It is a statement that is either true or false. So it can either be true or it can be false. Now the question is, he is a lawyer. This is a proposition. This can either be true or this can either be false. Now, how are you going to ascertain that this statement is true? So when you talk about ascertaining, immediately you come into proof. So proof is a method to ascertain. So what method will you use to ascertain the truth. In this case, E is a lawyer. What would you do? Come on, answer me this question. You would simply go to the place where this person is practicing law. I would say you will simply go to the court. And what would you do? Going to the court, you will observe the gentleman in action. So the all-important action that you are doing is observation. Now going further, after you have observed, you would really want to confirm the truth that he is a lawyer. Now if I were to add a single word between the indefinite article and the term lawyer, say good lawyer, then this proposition gets more weightage. And the method, I started saying that you go to the court and you observe this gentleman in action. To ascertain this proposition's truth, you need to add one more element that is called as experimentation. 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 And these two actions will give you the ability to ascertain if this proposition is true or false. So what would you do? You will simply give a case to the gentleman and see his performance, or I would say and observe his performance. So this is one part, how we exactly ascertain if a given proposition is true or false. Let me write down the technique: observation and experimentation. So this is a technique. Now the famous example for this would be Isaac Newton's discovery of acceleration due to gravity. We all know Isaac Newton, the greatest scientist who was responsible in getting a very important constant, which is called as acceleration due to gravity. And how did he get the constant? We all know the constant is represented as lowercase g, 9.8 meters per second squared. This is the value. What really prompted Isaac Newton to get into the area of gravity? It is said that Isaac Newton was sitting under a tree. In fact, he was sleeping under a tree, right? And then an apple fell on his head. Now, immediately he observed. So what did he observe? He observed that apples are falling down from the tree. Now he prompted a question to himself. He said, why should they fall down instead of going up? So he conducted a series of experimentation to substantiate his observation. So that would be a great example for our first all-important method. Now let's move on. Now there is another way also to ascertain the truth or ascertain the validation or validity of a proposition, and that technique is called as sampling. L-I-N-G, right? It's called as sampling and providing counter examples. So what would be the best example for this particular method, sampling and counter example? Now there is a story. There was a shepherd boy and he had a boss. Now this boss is a very wicked guy. He is a very wicked man. But this shepherd is a man who is minding the sheep. So this shepherd boy, one day he goes up to the master, his boss, and tells him, "Sir, I have worked with you for 7 years and I want to go home now." Now this wicked man says, "I can't send, okay, I'll send you home. You can go. You can go." So immediately the shepherd boy says, "Sir, I have worked with you for 7 years, but you did not give me, you did not give me my wages for 7 years. This might happen. You might be wondering, wow, is it possible to see such a scenario in this day and this age? It is happening all the time. You have to go read the news. I'm talking about something which happened 4,000 years ago. A story which is known 4,000 years back, or probably 6,000 years ago. Now, this master, the owner of the flock, he says, "Okay, you can go." But the shepherd says, "You did not give me my wages for 7 years. So for that, this person, this owner says, "All the sheep that has some spots on them belongs to you, is yours. So all the sheep that is born," he adds one more thing, "that is born from now onwards, and that has spots on them is yours." You see the clause he is giving. All the sheep that is born from this time forth and which has spots is yours. But do you know, to have a sheep with spots is a rarity. It's very rare. It's very rare. Have you seen a sheep with spots? When I say spots, I mean like this. Some dark coloring, some black colors on the sheep, or it can also be brown color. Brown or black colors on the sheep. It will be spot like that. This is a big challenge for this small shepherd boy to get some wages from this wicked master. Now, what does he observe? Observation. We are coming back to the concept of observation. He has observed before birth, before a sheep could give birth, if they drank from a drinking hole. So as they were coming to drink, he had already observed that whenever the sheep were about to drink from the water bowl, by placing certain branches from a certain tree, the sheep that gave birth always produced spots on the baby sheep that were born. What exactly did this simple shepherd did? He had observed, and then he had also experimented. But between the observation and the experimentation, he had this sampling going on. He sampled, he took a group of sheep and he sampled with suitable counter examples. He would have done that. Counter examples means what? If he would not have placed these branches, then they would not have produced those spots while giving birth. So you got the sampling, taking a group of sheep and then trying that out. and then subsequently producing the samples. A counter example. That's a way to say. So this is the next way in real life that people approach. Okay, now let us start with the mathematical part. What is a mathematical proof? This is an important concept. What is a mathematical proof? I can state that here. A mathematic proof is a verification of a proposition by a chain of logical deduction from a set of axioms. So the important point is logical deduction from a set of axioms. So these are the following important keywords that you will have to take note of. Now let me give you an illustration for this. Now this is the proposition. It is listed as follows: C union A. Now I will explain to you all these things. C union A means C is combining with A, and then there is an intersection that is performed with C union. And the claim of this proposition is, if such an action is to take place, then that would result in producing C. And we are given this diagram. This is A, this is B, there is an intersection, and this is C. Now my question is this proposition true or false? So mathematically we need to obtain a verification of this proposition by a chain of logical deduction from a set of axioms. So axioms means properties. Now C union A intersection C union B, this can be actually written in this following fashion. How do I write it? I write this as C union of A intersection B. What is this? This is nothing but what we call it as the distributive property. And what is A intersection B? Check it out. A intersection B is contained in C. So I'm writing it as C. What is C union C? It will again be C. So is this proposition true or false? It is true indeed. Now you might be wondering, what is this? This is the axiom that this proposition has to follow. That is the simplest way to understand the mathematical verification. Of course, there are a lot of new terms, and you will learn all these new terms as we proceed, as we progress. Now let me go one step further. Imagine you have a proposition like this. There is a proposition. It is stated as follows: for every n element of capital N, n squared positive N positive 41 is a prime number. Now what is capital N? You will learn it as we go further in the course. This is nothing but set of natural numbers. Natural numbers. Now what is the rule that this set has to follow? This set has to start from 1, and then the next number should be 2, followed by 3, 4, and then go on up to infinity. So this is an infinite set. Now when we say this symbol is called as for every. For every n, it can be any element. N can take any element from the set. This is actually called as a quantifier, and this statement is called a predicate. And the predicate is a proposition whose truth depends on the value of the variable. So this is a very important understanding of the term predicate. What exactly does it mean? The truth depends on the value of the variable. Now we got this predicate n squared positive n positive 41. Now we need to get the value. Now we all know what is the prime number. The lowest possible prime number starts from 2, and this is the only even prime number. The next one is 3, 5, 7, 11, 13, 17, 19, and so on and so forth. It goes on. Now the question is, by taking n is equal to 0, definitely we are going to get 41, which is a prime number. N is equal to 2. You will produce prime numbers for all these values. N is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, up until 39 values, you will get a prime number when you substitute. But this proposition will fail when you take n is equal to 40. So when I take 40, this is going to be 1600 plus 40 plus 41, which is nothing but 1681. And this one is not prime. This one is not a prime number. The next number for which this will fail is 41. 41 squared plus 41 plus 41. This is going to be 41 squared plus 2 times 41, which is nothing but 41 or 41 plus 2. Right? This is not a prime number. So the point I wish to say is, this is how we check the value and then verify if the predicate is true or false. I hope you are able to catch the beauty of the subject. Now let me go further. Now this is next proposition. For any ABC, B, C, D, which are element of integers. So integers, as I mentioned to you, it is again the definition of a set. Integers is a set, and it starts from negative infinity, goes up to negative 1, 0, 1. I've already defined, as we move up in the subject, I defined the set of integers. Now according to this proposition, for any ABCD element of set of integers, a raised to the power of 4 positive b raised to the power of 4 positive c raised to the power of 4 is equal to d raised to the power of 4 as no integer solutions. So what does it mean? It means it is impossible for you to find a B, C, D present in the set Z that satisfies this requirement. A raised to the power of 4, b raised to the power of 4, c raised to the power of 4 is equal to d raised to the power of 4. This proposition was given by the great Euler, and nobody were able to prove this for greater than 2 centuries. For more than 2 centuries, nobody proved this. So does it mean that proposition is actually true? It is impossible for you to find a B, C, D such that a raised to the power of 4 b raised plus b raised to the power of 4 plus c raised to the power of 4 is equal to d raised to the power of 4 as no integer solution. Can we take it like that? Apparently, some great man has disproved this proposition. He had found that there is a which is 95,800 and a b which is 217,590, and there is a c which is 414,560, and there is a d which is 422,481, which when substituted here gives us left hand side is equal to right hand side. So we have the values that proves definitely a raised to the power of 4 plus b raised to the power of 4 plus c raised to the power of 4 is equal to d raised to the power of 4 for these values. So this is a beautiful illustration how we understand proposition and how exactly we utilize the extraction of values to prove the predicates. So having mentioned this, let us move on. Okay, one more illustration I would like to give you. Now, there is this proposition. It states as follows: 313 x to the power of 3 positive y to the power of 3 is equal to z to the power of 3 as no positive integer solution for every x comma y comma z element of z. Now this proposition has been proven to be false. In other words, there is a x comma y comma z element of z such that 313 times x to the power of 3 positive y to the power of 3 is equal to z power 3 does have a positive integer solution. And do you want to know the order of these values that were found to satisfy this equation? Left hand side is equal to right hand side. The order happened to be found 1000 digit long. When I say order, it means the smallest number that proved this, left hand side is equal to right hand side, is a 1000 digit long number. Now you may be wondering, why would I be interested in finding the values for x and y? Or in other words, why would I want to factor these large numbers? But you will have to understand, factoring is a very important. Factoring is a very important concept. Specifically, factoring of large numbers. It's very, very important area. As I mentioned to you, without factoring, there wouldn't be any crypto systems at all. And the most popular crypto system is RSA. Do you know RSA system, the effective so-called crypto system, can be literally breached with the knowledge of factoring? Now you may be asking, what is this RSA crypto system? Now RSA crypto system is a public encryption. Let me write that down. Public key encryption system that is used for data transmission. Now, why do we need data transmission? If there isn't any data transmission, then you would not be able to perform any online commerce. There would not be any e-commerce. No e-com. Because only through e-commerce, you're able to buy things online. So without public key encryption system, you wouldn't be able to transfer data securely. And the most powerful crypto system utilized for this is RSA. And with the knowledge of factoring of large numbers, it is possible to breach. So to avoid that, you need to be aware of the entire system of factoring. Now, usually before, the system was utilizing, the RSA system was utilizing 100 digits for designing its public key. But now they are using 1000. Still, to design a secure public key encryption, you need to have a greater in-depth knowledge of factoring. So that is where all these systems and equations comes into play. So in this class, I hope I have given you a detailed outlook as to why do you need to study mathematics, specifically discrete mathematics, and in particular the various areas of discrete mathematics. So having mentioned you all this, let us start off with the first topic on sets. Welcome students, we are starting our new section which will be dealing on sets, and this is a very important topic. Not only that it's important, it is also easy to understand and you can score a lot of marks in this particular topic. So having mentioned that, it is imperative that you have a clear understanding of this particular topic. So I will be starting all the way from basics and I will be moving on, slowly gravitating to introducing advanced concepts. So foremost, the all-important question is, what is a set? Now this is important. Now when we talk about set, you can relate set to a group, right? But the mathematical definition for a set is as follows. So a set is a well-defined collection of objects. This is the most important definition you will have to know. Well defined, that is the key word. If this is not present, then you can't call it as a set. Now, next important point you will have to know is there is a subject associated with the set. Let me give that also. So, study of sets is called set theory. Now, this is a full-fledged subject if you were to get into a university. Now, what is set theory? Now, if someone is asking you what is set theory, you can either say it's study of sets. That's a basic thing. But there is also a definition for set theory. So it is a branch of mathematical logic where one learns about sets and their properties, right? So that is just a side note for you all. Okay, so I've given you a definition for set and set theory. Now, next important thing is the origin of set. Who really was responsible? So let me give that statement also. Set theory origin. Who was responsible for this? You have to know this person. His name is George Cantor, right? So this particular suffix or the second part of his name, there is also a famous theory associated with this. So this great man was solely responsible for creating this particular subject, right? And it is, some people say it is 1990, some people give it as 1980. So he is a great mathematician, and he was the one who initiated this concept. He was the one who initiated this concept. So having given you this, let me just give you some illustration on sets. Say for example, this is an example for a set. 2, 4, 6, 8. This is example 1. Example 2, this is also an example of set, right? All even numbers. Now what's the difference between this and this? This starts with 2, 4, 6, 8 and this starts, or this has a phrase all even numbers. What's the difference between this and this? This is finite, this is infinite. So clearly you know that sets also accommodate the concept of infinity. Okay, let's move on. Next is, how do you represent sets? How do we represent sets? Now, there are popularly two main ways in which sets are represented. So, one is called as the rooster form. This is also called as the tabular form. Tabular form. And the other one is called as the set builder form. Set builder form. In abstract algebra, you will be using set builder form. So have that in mind. This is a very powerful form which is actually used. Not only that, in the area of data sciences, now they are utilizing set theory concepts in data sciences a lot. And the very fact the language Python is so popular is because Python has a specific data type. There is a specific data type in Python that actually has sets as its data, right? One of the data types. Actually, there are 4 major data types in Python, and one of them is sets. So it is imperative that you understand this concept of sets. Now, since I mentioned the 4 data structures or data types in Python, let me give you the other 3. One is already I've given you, sets. The other 3 would be list and tuple, and then the Last one is dictionary. Of course, they are not in that order. So if you are learning Python, you will start with list and then you will enter dictionary followed by sets and tuple, or depending on whatever be the introduction that you receive. These are all actually built-in data types. They are called as built-in types, built-in data type. So that is just a side note for your understanding. Now, why did I give you that? Because I wanted you all to be well informed with regard to sets. Okay, now let me talk about the rooster form. Now, in rooster form, all elements of the set are listed, separated by comma and enclosed by flower parenthesis. Now this is called as flower parenthesis. Some people use some other name, but the actual way to call this parenthesis is as flower parenthesis. I just gave you an example. In the first case, I gave you an example like this: 2, 4, 6, 8. Now in this case, I can give an illustration as 21, 28, 35, 42. This is also an illustration. Or you can also give another example. Example 1986, 1987, 1988. Such examples are always fine. Okay, so that is for the rooster form. Now let me come to set builder. As I mentioned to you, this is a very important notation. Set builder form. Now what is this form? Actually, in set builder form, we set a property, a common property that all elements should follow. Now another word for follow can be comply. So they will have to comply. If they want to be in that particular group, they will have to comply. So that is the only way, and it's a powerful word. In the previous example, I was just talking to you about even numbers. Now we can have something like this. We can say example 1. This is the way we use set builder form. I'm taking all x slash x element of integers, and I can put in a condition like this, in this following fashion: x is even. Now, how do you read this? We can state it like this. Say collection of all x. The slash means such that x is an integer. Colon also means such that. Okay? Such that x is even. So there are two requirements that the value x should follow. One is that it has to be an integer, and that it has to be an even integer, and only then x can actually be in this particular group. Now, having mentioned to you about the different forms, now how do we actually represent set? That is also an important part that you will have to know. Now the representation is critical. The representation of a set. Remember, always, okay, this is an important point, always a set is represented using uppercase characters in the, now I'm using alphabet, right? Now this alphabet is the script followed by a language. Now when I mention this word alphabet, it can be any characters in a language actually, which we are, when we talk about language, we are talking about the Anglo-Saxon forms that are used, or in other words, the Latin-based language. So we will be using that form. But if you are coming from some other background, then you can suitably use your form of representation. So that is an important point I thought I should mention to you all. Okay, now the next important information that you have to know is what are the different types of sets that are available. Now I just started off saying that finite and infinite, right? If you remember, I started by introducing that concept. So now I will inform or I would say present to you all the other concepts connected with types of sets. So what are the types of sets we got? Number one, finite set. Finite set. So what is the finite set? The number of elements in the set is finite. That is the simplest way. Now, can I replace finite with the term countable? Can I replace finite with the term countable? No, because this itself is a concept. Countable in itself is a concept, so we cannot do that. You have to stick to this particular word, finite. There is no alternative. You cannot replace it with any other word. Now, infinite. Infinite set. So what is an infinite set? The number of elements in the set are infinite. So can I replace this word infinite by not countable? No, cannot. You have to stick to this terminology, infinite. Okay, the next comes empty set. Empty set. So what is an empty set? A set with no elements. Now you might be wondering, what is this? A set with no elements? What's big deal about it? Why should I take it? Now you have to understand, empty set is a powerful concept. Why? If a set is empty, it is just like a container is empty. That means something can be placed inside, right? This is a very important concept in Python, specifically when you are dealing with data sciences, right? So don't think that empty sets are what big deal in it. No, it's a powerful concept and we need that. Without that, you cannot literally have the field of data sciences. That's a better way to say. Now, singleton set. Singleton set. A set with one and only one element. Right? I'm just emphasizing one and only one, nothing else more. Number 5, equal set. So what is the equal set? Two sets are equal if they have same elements. That's important. Two sets are equal if they have the same element. So this is the catchword, same elements. Number 6, I'm trying to squeeze in one more. Equivalent set. EQUI. VALENT, equivalent set. Two sets are equivalent if they have the same number of elements. Same number of elements. It doesn't matter that whether they are equal or not. Same number of elements. It doesn't matter if they are equal or not, but they should have same number of elements. So that would mean any set which is equal can also be called an equivalent set, right? But any set which is equivalent cannot be called an equal set. So that is the catch point. Okay, I have run out of space and I will have to move up to the next page, right? So this is the beautiful introduction for set which I have done for y'all. So that looks really amazing. So we started, just to give a recap, We started with what is a set. A set is a well-defined collection of objects. Then study of set is called as set theory. George Cantor was responsible, and I also mentioned to you, in some areas they say it is 1918, in some places they give us 1919, right? So, and then we gave an example for a set. 2, 4, 6, 8 is an example for a set, and all even numbers is also another example for a set. Now there are a wide difference between these two sets. One is finite, the other is infinite. Now how do we represent a set? There are two predominant ways sets are represented. One is the rooster form and other is the set builder form. And over here I said set builder form. Set is a very important concept that you will have to get a grip of. Why? Because it is so powerful that it is treated as a built-in data type in Python, right? The other three data types are list, tuple and dictionary. So I emphasized the need to get a mastery on sets. Now the rooster form, all elements of the set are listed using using commas, and then I went on to deal with the other set builder form, and then we add the different types of sets: the finite set, infinite set, empty set, singleton set, equivalent set. The list is not finished. I will have to move on. So let me just go up here. Okay, that's fine. So next comes the power set. This is also a very important concept. Power set. So what is a power set? Set that contains of every possible subset. Every possible subset. Right? A set of every possible subset. So we will have to see illustrations for this to have a better understanding. And next is the all important universal set. So what is the universal set? Any set that contains all the sets under consideration, right? So that is the universal set. Okay. Finally, what is a subset? When all the elements of a set, say set A belongs to another set B, then we say, what do we say? We say that A is a subset of B. Now I used indefinite article over here because B can have many subsets. So that is the understanding that we need to have here. Now, after giving the description on sets, it is also important for us to know other existing sets that are actually, just as in Python you got pre-built data types or data structures available. In mathematics, specifically in algebra, we got what is called as pre-built-in sets. So I'm going to give you some pre-built-in sets. So what exactly does it mean by pre-built-in sets? These sets are already available. You don't have to create them. There is no need for us to create them. So foremost, we start with natural numbers. Okay, we call it as set of natural numbers. Okay, natural numbers are also known as God-given numbers. So these numbers were already there. Nobody knew how these numbers got started. There is no evidence to point that, okay, this person literally was responsible in creating, and he lived in, say, downtown Berlin or downtown Moscow. We don't know. Nobody can really state that. So that's why they call it as God-given numbers. Now, next is set of whole numbers. Now, you have to understand, this is represented with a capital N and with a stroke there. That is how you represent natural numbers. Whole numbers, capital W with a stroke there. This is called a set of whole numbers. Set of whole numbers. And let me give you the set of natural numbers over here. So it starts with 1, 2, 3, 4, 5, and it goes all the way, never ending. It ends at infinity. So it is continuing on. Now in set of whole numbers, there was a new addition, 0, 1, 2, 3, 4, and it goes on to infinity. Now this 0 was invented by a mathematician called as Aryabhatta. Gentleman was an Indian mathematician who invented, and he placed this whole numbers, and they started calling it a set of whole numbers. And without 0, you all know there is no field of computer science. If 0 is not there, there is no field of computer sciences. And we know computer sciences literally are found in every field and any field for that matter. And now everything is digitalized. And the computers can understand only two things. What are two things they understand? They understand 1 and 0. This is a beautiful logic, you see. 1 and 0. This is a very, very great philosophy that is present here. Unimaginable philosophy. You see, the world is actually run by computers. And computers can understand only two things. 1 and 3. One set of numbers, the natural numbers, as I mentioned to you, is God-given numbers. And the next set of numbers, there was a slight addition by man, called Aryabhatta, into the set, and that is 0. So that's a powerful concept. Okay, now so much so for that concept. Let us move on. After the natural numbers and whole numbers, we got the set of integers. Okay, this is called as the set of integers. Now, what exactly is this set? In this set has got two other sets within it. One is called as the set of positive integers. The other is called a set of negative integers. Now, in set of integers, when you talk about set of integers, the set of integers are actually written like this: 1, 2, 3. It goes up, and then 0, 1, negative 1, negative 2, negative 3, negative 4. It goes on like that. And in this case, it goes like this. Now, apparently, we cannot decisively say is 0 an integer or not. Now, some people will say 0 is an integer. We cannot decisively say 0 is actually placed there as a buffer, right, to separate negative integers from positive integers, right? So I have mentioned that if someone were to outrightly ask you, is 0 an integer? Is 0 an integer? What would your answer be? Or to be more definite, is 0 a positive integer? If 0 a positive integer, then the set of positive integers should start with 0, but they don't start with 0. They start with 1, 2, 3, 4, 5, and so on and so forth. And if 0 a negative integer, they will have to start with 0, but they don't start with 0. So negative 1, negative 2, negative 3, negative 4, and so on and so forth. So in either of these cases, you can see 0 is not present here. And the set of integers is actually the set of positive integers along with set of negative integers. So 0 is not actually present in the set. But when we are writing, we write it like this. When we are representing the set of integers, this is the way we represent. So again, there is some mathematical philosophy present there. Now next comes Q. Now what is Q? Q is nothing but the set of rational numbers, right? Now, when I use the word rational numbers, you will have to know what is a rational number. What is a rational number? Can anyone tell me? What is a rational number? Okay, this is a very important question. What is a rational number? Let me state it. A number of the form P divided by Q, where Q not equal to 0, is called a rational number. Any example for rational numbers? Say 5 by 8 is a rational number, 5 by 7 is a rational number, 1 over 2 is a rational number, 5 is a rational number, 7 is a rational number, so and so on and so forth. 1 over 20 is a rational number. So these are all some examples of rational numbers. Okay, a number of the form P divided by Q, where Q not equal to 0, is called a rational number. Okay, so these are all some pre-built in sets. Now next comes real numbers. Of course, there is also called as irrational numbers. Okay, this is also a very important concept. Irrational numbers. So the definition is numbers which are not of the form p divided by q. Example of irrational numbers would be root of 2, root of 7, pi, e over pi, e raised to the power of pi, pi raised to the power of e, log 3, and so on and so forth. So these are all some of the examples of irrational numbers. This is the representation for a real number. So a real number is a composition of rational number plus irrational number. So this is a composition of rational numbers plus irrational numbers. That is for the set of real numbers. So all these things are sets. Next, another important powerful concept is complex numbers. Complex numbers. So this is also called a set of complex numbers. What is a complex number? Again, a very vital question. What is a complex number? What do you call it? What is a complex number? A number of the form a plus ib. You can write as a plus ib or x plus iy, such that a represents the real part and b represents the imaginary part. So these are some of the basics that you will have to know. Now, after giving you the information on sets, let us move on. These are the notations that you will have to know. So the first notation, notation 1, this is called as a flower parenthesis. As I mentioned to you, this is the flower parenthesis. And what is this used for? This is used to represent a set. Okay, number 2, when I say like this, A, U, B, what is it? This means A union B. Number 3, what is it? A inverted U and B. What is the meaning of this? This means A intersection, INTERSECTION, intersection B. A intersection B. Number 4, okay, I draw a C like this and I place the line, and then I place B there. So what is the meaning of this? A is a subset of B. Number 5, I place it like this, A, and then I give a C like this and I strike it. What do you mean by this? A is not a subset of B. 6, I write A, I draw a C like this, I don't place any lines, and I place B there. What is this? A is a proper, it's called as a proper, it's a very important concept, subset of B. A is a proper subset of B. Okay, number 7, symbol which I've used, it can be reverted, or I should say, instead of placing it like this, I can also say like this. So what is the meaning of this? In this case, you will have to say B is a proper subset. B is a proper subset of A. Now, let me just use this space here. Now, if I were to write it like this, A, C, B, and then I give a strike, this means A is not a proper subset of B. Now, this symbol stands for empty set. When you're writing empty set, do not, let me use the space here, do not place, if you want to represent empty set using the set theory logic or set theory representation, you can also do that. You can either represent an empty set like this or like this, but do not place it like this and place the symbol inside this. This is incorrect. Okay, don't do this. You cannot do this. because in this subject you have to follow the rules even when it comes to representation, and if you don't follow the rules, it means it's a mistake, it's an incorrect representation, or it's an incorrect answer. So that's the way mathematics works. I always tell my students in mathematics, when you say like this, 7 plus 8, this is 7 plus 8, and when you say like this, 7 minus 8, it is 7 minus 8. There isn't anything other than this. If you want to add 7 with 8, and if you are giving this representation and you are expecting the output to be as 15, then you are dreaming, right? This is not going to happen, because you have just placed the representation or placed the operation that has to be carried out between 7 and 8. So as you all know, plus and minus and division and multiplication, they are all operators, and they are highly, what I would say, powerful operators, and they are very unique in their characteristics. That means a plus will only add things, a multiplication will only multiply things. So you got to be careful. So having given you that statement, let me just move on. Now at times you have this notation also, P of A. Now this is called as power set, right? So when you study about power set, you will be introduced. Okay, now if I were to write it like this, A is equal to B, this is for equal sets. So this means set A is equal to set B, equal to set B, or you can simply say two sets are equal. Now in complements, we also use a C here, or you can give a slight dash here. This certain textbooks follow a dash, certain textbooks place a C there. So depending upon what textbooks you come across, so this would mean complement. I will explain to you complement of A, complement, C-O-M-P-L-E-M-E-N-T. And if you want to represent something like this, A, the symbol, and capital A, what is the meaning of this? This means A is an element of the set A. This is the element, this is the set, that you will have to understand. Now instead of writing like this, if I were to strike this off, let me use this space here. Now if I were to say A element, strike it off, and B, this means A is not an element of A, right? I hope you got that. This is the understanding. So this is all that is required to start with sets, but I'm not yet finished. I will have to give you the operations on sets and the formulas on sets, and then we are going to be doing some related questions. So this is beautifully done. Let us see what are the operations that can be performed on sets. The following operations can be performed on sets. Now what are those? The first popular operation is called as union. The number 2 is intersection, I-N-T-E-R-S-E-C-T-I-O, intersection. Number 3 is complement. Number 4 is difference, D-I-F-F-E-R-E-N-C-E, difference. Union, intersection, complement, difference. Now important formulae which you have to know. Important formulae in sets. You got to know this. What are the important formulas? Now the first most popular one, N of A union B. Number of elements in A union B is equal to N of A plus N of B negative N of A intersection B. Now this is a very popular formula. And even in probability theory and statistics, this is used widely. Now the next one, formula 2 comes, n of A union B. Now there is a requirement for this formula. Let me give you n of A plus n of B. Now what is the requirement? A and B are disjoint. What do you mean by disjoint sets? There is nothing common between these two sets. Now disjoint sets is actually a powerful concept. It is applicable in social sciences and in several areas of developmental sciences also. Because if there isn't anything common between A and B, then these sets are actually highly individualistic in nature, right? They are, what do we call them, as independent. So let us move on. Now next comes n of u. U is a universal set, and if you want to know n of u, then it's nothing but n of A plus n of B, negative n of A intersection B, positive n of A union B, but there is something you need to place here, n of A union B dash, that means complement. We're talking about A union B complement. That means you got to find A union B, and then you'll have to find the complement of that. I will explain to you when we come out to that particular operation. Number 4, n of A union B. There is also another representation. This is also a very important formula. Very important formula in the sense, instead of this, you can also utilize this, but with a variation. Because this uses difference. So this is equal to n of A dash B. We call this as A difference B plus n of B difference A. A difference B and B difference A are not the same. They're different. Right? Plus n of A intersection B. So that's a formula. And next is formula 5. N of A difference B is equal to n of A intersecting B followed by negative sign and n of B. And number 6, n of A difference B, this is also acceptable, is equal to n of A negative n of A intersecting B. Now I will stop with number 7. This is n of A union B union C is equal to n of A plus n of B plus n of C, negative n of A intersecting B, negative n of B intersecting C, negative n of C intersecting A, positive n of A intersecting B intersecting C. This is a very important formula, right? So we have completed all that we need for working out problems on sets. So next thing is we will work out some examples, students. Now in this class we will start off with problems and solutions connected with sets. So foremost, this is question number 1. We got a universal set to be equal to A, B, C, D, E and F. We got set A to be equal to A, B, C. Set B is equal to C, D, E and F. Set C is equal to C, D and E. Now we are asked to find A intersection of B union A intersection of C. This is what we've got. Now foremost, the solution, we need to start off like this. Solution, consider A intersection B. What is that? What is the set A? Set A is A, B, C, intersection of set B, C, D, E and F. Find out what is common, right, between A, B between A and B. So is there anything common? So I got a C here, I got a C here. That's it. So A intersection B is equal to C. You got to write it like this. Next, consider, what's the next thing you need to consider? A intersection C. What is A? A, B, C intersection with C is C, D, E. What is common? Just C is common. So write that down, equal to C. Now, therefore, A intersection B union of A intersection C, A intersection B is C, union A intersection C is C, C union C is what? Just one C. So that's the solution, right? So this is the solution, A intersection B union A intersection C, and probably you can put it in a box. Now question 2, give 3 examples of finite set using set builder notation, right? So example 1, so let me start with capital A. A is equal to all x such that x is greater than -2 but less than or equal to 5. This is an example, so using set builder notation, right? So number 2, B, all x such that x should be an element of numbers. Say I'm giving a square parenthesis here, right? So between or starting from 0 to 21. Oh, this should be the flower parenthesis, right? Not square parenthesis, flower parenthesis. So this is a flower parenthesis. This is a flower parenthesis. So I've given, this is also a finite set. So finally, say C, collection of all x such that we got x to be lying between x is greater than, say, -21 and x is lesser than equal to +21, and we can include one more condition, x is divisible by 3. So this condition, or both these conditions have to be satisfying for extracting values for x. Greater than -21 but less than +21, and such that x is divisible by 3. Okay, so these are the 3 illustrations that we can give for this particular question. So let's move on. Okay, this is example number 3. We've got u being given. U starts from 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, and A being 3, 5, 7, 9 and 11, and you got B being equal to 7, 8, 9, 10 and 11. We are expected to find A difference B, the complement. Okay, now first let me start off like this. Consider A difference B. So write down the set A, which is 3, 5, 7, 9, 11, minus B is 7, 8, 9, 10 and 11, right? When you state A difference B, it means from A you remove everything that as the elements of B. So I'm starting off like this. So from this, remove everything that B has. So B has 7, take 7 out. B has 9, take 9 out. B has 11, take 11 out. The number 10 and 8 are not there, so we don't have to worry about it. So after taking away the elements of B, what have you got? Write that down. You got 3 and 5. That's it. So this is A difference B. But we are expected to find A difference B complement. What is that? That is nothing but from U, you take away A difference B. Now what is that equal to? My U is 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. This is my U, and my A difference B is what? 3, 5. So from this take away 3 and 5. So I take away 3, I take away 5. So what do I get? I got 2, 4, 6, 7, 8, 9, 10 and 11. So this is the solution, okay, for this question. Let us do this question, students. This is question number 4. A is collection of all x such that x is element of natural numbers, and we got x to be less than 6. Now B is given to be as 3, 6, 9, and C is given to be collection of all x such that x is element of n, and that 2x negative 5 should be less than equal to 8. Right, so these are all some of the conditions that have been given. Show that, or they might ask you to prove that, show that A union of B intersection C is equal to A union B intersection of A union C. Right, so foremost what we will do is we will consider the left hand side. What is on the left hand side? A union of B intersection C. This is on the left hand side. So what we are going to do is, before we could start this, we will have to list out the elements of A. So let me do that. Let us list out the elements of A, B and C. So what do we got for A? Collection of all x such that x is less than 6. The x should be an element of natural number, right? So in this case, natural numbers start with 1. So 1, 2, 3, 4 and 5. That's it. And for B, it's already given. B is 3, 6, 9. And for C, collection of all x is an element of natural number, and it has to satisfy this inequality. So the first one, when I substitute x is equal to 1, right, I will have to first solve this inequality, right, simplify this. So what I would do is, on this part I will write this in this fashion: 2x negative 5. Instead of taking it as less than equal to, I'm going to say equal to 8. So that means 2x is equal to 8 plus 3, 8 plus 5, and that would mean 13. So 2x is equal to 13. So x is equal to 13 over 2. So the value of x that we are getting here is not a natural number, right? So we need to extract the values of x for which x is a natural number. So this would be 6.5. So we need to get values which are actually starting from 1, 2, 3, 4, 5 and 6. So that would be the set C. Now, as I mentioned to you, we have taken the left hand side, and in the left hand side we have A union B intersection C. So first step 1, consider B intersection C. What is B? 3, 6, 9 intersecting with C 1, 2, 3, 4, 5, 6. So what is the intersection? We got 3 there. Yes. You got 6 there. Anything else? No. I don't have 9. So this is equal to 3, 6. You can just write that down. B intersecting C. Okay. So now step number 2. You got to consider A union of B intersecting with C. What is set A? A is 1, 2, 3, 4, 5, which is present here, and that is uniting with 3, 6. So this is going to be 1, 2, 3, 4, 5, 6, right? So this is for the left hand side. Now we need to show left hand side is equal to right hand side. So step number 3, consider the right hand side. What we got in the right hand side? A union B intersection with A union C. So foremost what we will consider is we will work out for A union C first. So my A is 1, 2, 3, 4, 5. This is uniting with C 1, 2, 3, 4, 5 and 6. So this is going to be giving me 1, 2, 3, 4, 5 and 6. So this is my A union C. And then I will consider A union B. My A is, you can just write that down. Consider my A is 1, 2, 3, 4 and 5. Union B is 3, 6, 9. So this is equal to 1, 2, 3, 4 and then 5 and a 6 and a 9. So this is my A union B. So final step, step 4, therefore A union B intersection of A union C is equal to my A union B, write that down, 1, 2, 3, 4, 5, 6 and 9. This is intersecting with A union C, which is 1, 2, 3, 4, 5 and 6. So what is the intersecting value? So you are getting here 1 fine, 2 fine, 3 fine, 4 fine, 5 fine and 6 fine. You don't have 9 there. So what is this? Is what you are getting. So this is the right hand side. Now if I were to take this as 1, if I were to take this as 2, from 1 and 2 what do you see? From 1 and 2 clearly left hand side is equal to right hand side, hence proved, right? So that's a solution for that question. Now you have to get the solution for this question in 30 seconds. That is after I have completed giving you the question, okay, along with the choices. So let me start the question. Given A, B are subsets of the universal set, then what is the value of A intersecting with U difference B, and that is having a union with D? The choice is A Is it A? B, is it A intersecting B? C, is it A union B? And D, is it the universal set? So your time starts now. You can give the solution. Okay, now let me give you the solution. I hope if you have got the solution, then place that solution choice in the comment box. If it is correct, I will give you a heart. If it is not, then you will have to go through that entire notes on set theory, whose link I will place it in the comment section or in the description box. So let's start the question, right? So this is what is given. A intersection of U difference B, and this is performing a union with B. Now foremost, U difference B, that is what? That is B complement. So this is A intersection of B complement, that is uniting with B. Now A intersecting some quantity, some set with union. This can be rewritten in this following fashion. A union B intersection of B complement union B. Now B complement union B, what is that? That is nothing but U, and this is intersecting with A union B, right? Now A union B intersecting with U, what is that? That is nothing but A union B. So the right answer for this question is C. To prove this, A difference of B complement union C complement should be equal to A difference of B intersection C, the whole complement, given that U is collection of all X such that X is a natural number and that X is divisible, or I should say that it isn't divisible, it is actually present between 5 and 20. So all values of X such that X is element of natural number and X should lie between 5 and 20, right? Probably I will give lesser than equal to sign there. And we got the set A. Set A is all X such that X lies between, X is element of natural number, that is obvious, and that X is lying between 5 and 20, and that X is divisible by 3. Divisible by 3. So all these conditions have to be met by the set A, right? And for B, collection of all X such that X is element of natural number and that X is present between X and 20. And one more condition, and that X is even number, that X is even, right? So greater than equal to 5 but less than equal to 20, and X should be even number. So this is for B, and let's go for C. C is equal to all X such that X is element of natural number and that X is lying between 5 and 13. X is greater than equal to 5 but less than equal to 13. And of course all of these things are given in set builder form, and we will have to obtain the elements. So universal set, that's the easiest one. Universal set is all X element of natural numbers that is lying between 5 and 20. So we start with 5, 6, 7, 8, 9, 10. Let me make it as less than equal to, because all of these things are less than equal to. So it's better that I should have less than equal to there. So less than equal to, so 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So this is the universal set. It starts from 5 and less than equal to 20. And all of these things should be within the universal set. All these sets A, B, C should be within this universal set. And that is the reason I have made it to be less than equal to, because initially I just took it as strictly less than. But apparently I later on realized that these elements are actually hitting 20. And we need to make sure that the universal set is the largest set. And that is clearly acceptable in this case. So set A is actually strictly greater than 5. This is all right. It is within the bounds of the universal set, but strictly less than 20, and x is divisible by 3. So strictly greater than 5, that means we start with 6. Divisible by 3 means the next element would be 9, and then 12, and then 15, 16, 17, 18, 19, and 20. We cannot take that. So this is the set for A. Okay, set B is equal to between 5 and 20 and all even numbers. So 6, 8, 10, 12, 14, 16, 18, and 20. Right? And finally C, all elements of x such that x lies between 5 and 13. So we start with 5, 6, 7, 8. Right? So this is the first step. We need to get it on board. And once we get this on board, everything else is cakewalk. Now B complement. So consider the left hand side. So what's on the left hand side? A difference of B complement union C complement. Now in particular we will consider B complement union C complement. Okay, so we start off with B complement. So we can state that we know that B complement is equal to, from the universal set you take away everything that belongs to B. Right? From the universal set you take away B. Everything that belongs to B would be B complement. And that's exactly what I'm going to do. So from universal set we take away B. What happens when we take away B? So let me use this instead of writing it again and again. So I take away 6. If I were to take away 6, I will end up with 5. I take away 8, I'll have 9 there. I take away 10, I'll have 11. Take away 12, I'll have 13. I cannot have 14, I'll have 15. 16 is there. 17, I take away 18, 19. Right? So this is my B complement. That's fine. So I have got my B complement. Now I need to extract my C complement. Right? So C complement is nothing but, from the universal set you take away C. I can put it like this. So this is equal to, let me go to the value of C. So 5, 6, 7, 8, 9, 10, 11, 12, 13. All this goes off, only these things remain. So that is equal to 14, 15, 16. Right, that's there. So now we got B complement union C complement. So these two are united. So that would give me right. Now I need to perform the difference. So therefore A difference of B complement union C complement is equal to my A. I'm writing my A. A is 6, 9, 12, 15, 18. So whatever that we see here should be taken out of A. Okay, minus B complement union C complement. So I'm taking away whatever I see. I see a 9, I take away 9. I see a 12, no. I see a 15, I take away 15. I see a 18, I take away 18. So 6 is there, 12, apparently 12 is not here. So this is equal to 6 and 12. Right, so that's for the left hand side. So now let me just go up and consider the right hand side. Consider the right hand side. So what we got in the right hand side? Right hand side is this. Right, so A difference of B intersection C complement. So in particular, consider B intersection C. So what is my B? I need to take you back to the question. My B intersection C. So I've got a 6, I've got a 8, I've got a 10, and I've got a 12. That's all. 6, 8, 10, 12. That's it. So this is going to be 6, 8, 10, 12. Now this complement. So B intersection C complement means, so therefore B intersection C complement means from the universal set you take away B intersection C complement. So that would mean my universal set would now be 6, 8, 10, 12. Take away 6, 8, 10 and 12. So what do you have? So that is going to be 5, 7, 9, 11, 13. Right, this is the universal set. You take away now you don't have to put this complement, right? I'm just there's no need for that. So B intersection C complement is nothing but from the union you take away B intersection C, and that is what we have got. So having got that, now we need to take this value. We need to hence A difference B intersection C complement. So from A we need to take away B intersection C complement. So what is A? Let me write down the value of A. A is 6, 9, 12, 15 and 18, and I need to take away everything that belongs to B intersection C complement. So let me do that. So I need to take away 9, I need to take away 15, I need to take away 18, and what do I have? I've got 6 and 12. So if I were to take this as 2, if I were to take this as 1, from 1 and 2, what do we see? From 1 and 2, we get clearly left hand side is equal to right hand side. So we just proved that, right? So this is a beautiful question. Students, we'll move on to the next one. Let's do this question. Students, the next question. So if A is given to be equal to collection of all x such that x is element of all numbers and that x lies between 5 and 10, and B is given to be as 3, 4, 5, 6 and 7, and C is collection of all x such that x is connected by means of the relationship x is equal to 2n, and n is element of natural numbers and that the value of n is less than equal to 4. Now we are expected to find B union A intersection C and that value is given to be as k, where k is nothing but sum of each element right. So that is the question. So when we talk about sum of each element, it means sum of each element present in B union of A intersection C. Now this question is solved when we list out all the elements for the set. So solution, let me start off with A. A is a collection of all x such that x is a whole number, and it starts from 5, not including 5, reaches up to 10, not including 10. So it's going to be 6, 9. That's all we got for set A. So place the parenthesis. Set B is given to be as 3, 4, 5, 6 and 7, and C is given to be as all values of n should be lesser than equal to 4. So they start with 1. Substitute 1, you get 2. Substitute 2, you get 4. Substitute 3, you get 6. And substitute 4, you get 8. So this is the first step that you need to get it right. Okay, so let me just consider A intersecting C. So what is that? I have to perform an intersection of A with C. Is there anything intersecting? Okay, 6 is intersecting here, and then 8. So 6 comma 8. Now we need to take B union of A intersecting C. Now my value of B is 3, 4, 5, 6, 7. This is actually performing a union with A intersection C. So that's going to be 6 comma 8. So this is equal to, if I were to unite these two things, it's going to be 3, 4, 5 and 6 and a 7 and an 8. So this is what we've got. So this is equal to k, therefore k is nothing but sum of these elements. So you need to write this step: 3, positive 4 and a 6 and a 7 and an 8. 7 added with 7, 14. This is 20, 28 and 33. So this is the value of k. K is equal to 33. Now this question looks easy to work, but the main problem will come in understanding the question. So that's an important part of this particular problem. To do this question, students, the question is stated as follows. Let Z be the set of all integers. We know Z represents the set of all integers, but questions will always give statements like this, mainly to confuse, and that A is equal to collection of all ordered pairs such that x to the power of 4 negative y to the power of 4 is equal to 175, and x comma y should be an element of integer. Okay, now if this is the situation, they are asking us to find the number of elements in the set A. This is an interesting question. Why? For the fact we are given an infinite set. Z is an infinite set, and we have to choose all x and y from Z such that this condition holds good. X to the power of 4 negative y to the power of 4 should be equal to 175. Now just imagine, is it easy to find out all the ordered pairs such that this condition holds good, and that too in a competitive environment? In other words, if this question is asked in a competitive examination, by the time we finish the question, the exam would have been already completed. In other words, the time would have already exhausted. So how are we going to do this question? Now, this is how you need to do this question. Rewrite x to the power of 4 negative y to the power of 4 as x squared positive y squared multiplied with x squared negative y squared is equal to 175. Next, write 175 as a product of numbers which you are happy with. Now I would like to divide 175 by 5. So 5 divides 17, 5 threes are 15, and 2 and a 5. 5 times 5 is 25. So 175 can be written as 5 into 35, and this 35 can be written as 5 times 7, right? So I got x squared positive y squared times x squared negative y squared to be equal to 5 multiplied with 5 multiplied with 7. Now I've got a product on the left hand side and I got a product on the right hand side. So what I'm going to do, by guess and check, I can take x squared positive y squared to be as, say, 5, right? If I take x squared positive y squared to be as 5, then x squared negative y squared should be 35. This is one probability, right? Now the other probability is, if I take x squared positive y squared it to be as 35, then x squared negative y squared should be equal to 5. This is the second one, right? Now I've taken x squared positive y squared to be as 5 and 35. Now I can also take x squared positive y squared to be as 5 times 5, 25. That's also possible. If I were to take x squared positive y squared as 5 times 5, then x squared negative y squared would be equal to 7, right? Now finally, this can also be one of the choices, right? I can take x squared positive y squared to be as 175 and x squared minus y squared to be as 1, and then go on and work it out. So these are some of the options that we have got. Now what I wish to do is, I would like to solve, right? I would like to solve them. So upon solving them, I would be in a better position to find out the values of x and y, right? So let me just go up and solve here. Now y squared gets cancelled. I get 2 times x squared, and this is going to be 40. So x squared is equal to 40 over 2, that's going to be 20. Now x is equal to root of 20. X should be an integer, right? So in this case x is not an integer, so we can't use this, so we drop this. Now similarly, this will be the same state, so we also drop this. Over here, y squared gets cancelled. I get 2 times x squared is equal to 25 added with 7 will give me 32. So x squared is equal to 16. So x is equal to plus 4 and x is equal to minus 4. So this is okay. We can take this. In this case, y squared gets cancelled. You get 2 times x squared is equal to 176, and x squared is equal to 88, and x is equal to root of 88. So we can't take this. We have to drop this. So the only values that we have got here is from this system. X is equal to plus 4 and x is equal to minus 4. Now when x is equal to plus 4, you can substitute it here. Okay. So put x is equal to plus 4 in, say, x squared positive y squared is equal to 25. So this is going to be 16. So y squared is equal to 25 negative 16. So y squared is equal to 9. Therefore y will be equal to plus 3 or minus 3, right? Now these are the only values of x and y that will satisfy this equation. X to the power of 4 negative y power 4 is equal to 175, right? So that would mean, this means the values of a can either be plus 4 and plus 3, or plus 4 minus 3 or minus 4 plus 3 or minus 4 minus 3, right? So these are the only possible elements. So what does the question want? The question wants us to find the number of elements. Therefore, the number of elements of the set A is equal to how many? 1, 2, 3, 4. So that's the solution. Students, it's a lovely question. This is the beautiful question, students. Two finite sets have m and n elements. The number of subsets of the first set is 112 more than the second set. Now we are expected to find m and n. Now let me give you the concept of subsets. Now if A is equal to say 2, 3 and 4, then the number of subsets possible for A is 2 raised to the power of n, where n is nothing but number of elements in A. Whenever we write n of A, it means number of elements in A. I will also specify it, number of elements in A. This is standard, n is standard. Right? So in this case, A is going to be 2 to the power of 3, which is nothing but 8. So the total number of subsets possible for the set A is 8. And A has got 3 elements. Now suppose if A has got say 5 elements, then the number of subsets possible for A is going to be 2 raised to the power of 5. So that's going to be 32. Right? So that is how we calculate the subsets. Now in this question we are given 2 sets. So let me write that down. Let A and B be the 2 sets such that it's given that the number of elements in set A is n and number of elements in set B is n, and such that the number of subsets of the first set A, number of subsets of A is 112 more than the number of subsets of B, right? So in this case, what is the understanding? What is the meaning of this? So this would mean if 2 raised to the power of m be the number of subsets of A and 2 raised to the power of n be the number of subsets of B, then it's given that 2 raised to the power of m negative 2 raised to the power of n is equal to 112, because A has got 112 more. You see that? The number of subsets of the first set is 112 more. So 112 more is found in A. So that's the reason I've written it like this, 2 raised to the power of m negative 2 raised to the power of n. Now what I wish to do in this case, I want to take 2 raised to the power of n out. So if I do that, this is going to be 2 raised to the power of m divided by 2 raised to the power of n negative 1 is equal to 112. This can be further rewritten as 2 raised to the power of n. I can push this up, rewrite it as 2 raised to the power of m times 2 raised to the power of negative n negative 1 is equal to 112. I can further rewrite this as 2 raised to the power of n times 2 raised to the power of m negative n negative 1 is equal to 112. Now 112 can be split in this following fashion. I'll start with 2. I want to actually use 2 as the smallest quantity. So I divide 112 by 2. This is going to be 2 divides 11 5 times, and then 6 times. Then 2 divides 56. 2 2s are 4, right? And then 28 times. Then 2 divides 28 14 times. Then 2 divides 14 7 times, and only 7 can divide 7 one time. So this is actually equal to 1 2 3 4, right? 2 raised to the power of 4 multiplied by 7. So I'm going to write this as 2 raised to the power of 4 times 7. Now from here clearly I can equate the terms, right? This is product of 2 terms on the left and product of 2 terms on the right. So from here I can write this as 2 raised to the power of n is equal to 2 raised to the power of 4. Bases are equal, so this would mean I get n is equal to 4, right? Now on the other end, watch here, I am using this part of the page. This is 2 raised to the power of m negative n minus 1 is equal to 7, the other quantity. I move this to the other side. This is going to be 8. So 2 raised to the power of m negative n is equal to 8. This is nothing but 2 raised to the power of 3. So 2 raised to the power of m negative n is equal to 3. So from here m negative n is equal to 3, but n is equal to 4. I substitute 4. So from here clearly I can write the value of m is equal to 7, right? So what have we done here? We have found out the value for n, and we have found out the value for m, right? So I can simply state here. So therefore m is equal to 7 and n is equal to 4. Now this technique which I have just shown you comes in handy to solve a variety of questions. Actually, it isn't necessary that this question ought to be asked in this fashion. They can literally flip this question in multitude ways, and no matter in how many ways they flip this technique would stand still and help you to cross the bridge. Let's do this question. The number of elements in A equal to, so we have been given as A comma B such that A squared positive B squared is equal to 50, and A comma B are element of Z integers, right? So we are expected to find the number of elements in A, and this is what is being given. Solution. Foremost, what we need to do is, let us take A squared positive B squared is equal to 50. Now let me draw the column here, A squared and B squared. Now you need to suitably choose the value for A squared and the value for B squared, so that when you add them up you get 50. Obviously the first choice would be 1 added with 49 is 50, but 2 added with 48 is also 50, but there is a problem. What is the problem? If I take A squared is equal to 1, then A can be 1 or A can be negative 1. That's fair enough. And B squared is equal to 49, and B is going to be positive 7 or negative 7. But if I were to take A squared is equal to 2 or A squared is equal to 4, then my B squared value will be equal to 46. From here I can clearly get A is equal to plus 2 or minus 2. But from here I get B squared, or in other words, if I were to take B squared is equal to 46, I will have B is equal to root of 46. But the requirement is A and B should be integers. Alright. So we will have to choose only those values. Even though A squared positive B squared gives us 50, we have to make sure that the values for A and B are strictly follows this requirement, right? So they should be in integers. If that be the status or that be the situation, then clearly I can get A squared is equal to 1 and B squared is equal to 49, and probably the next two values should be 25 and 25. That's the only thing I can think of. And if I were to revert this position, this will be 49 and this will be 1. In either of these cases, the values of A is equal to plus 1 and A is equal to minus 1. When A is equal to plus 1, B can be plus 7 and B can be negative 7. That's the first condition or the first requirement. Now A is equal to 5 or A is equal to minus 5. Similarly, B is equal to 5 or B is equal to negative 5. That's for the second case, and the last case will also repeat the first one which we have given you. So having given these cases, now it's time for us to write the ordered pairs. So therefore the ordered pairs can be listed as follows. When A is 1, B can be 7. When A is 1, B can be negative 7. When A is negative 1, B can be 7. When A is negative 1, B can be negative 7. So this is 4 cases. The next 4 cases can also be extracted in the following fashion. Now we can outrightly we can present this situation now, right? So instead of A being 1, A can be 7 and B can be 1. A can be negative 7, B can be 1. And A can be positive 7 and B can be negative 1, and A can be negative 7 and B can be negative 1. So we got 8 cases here, but for this positive 5, negative 5, they will give us only 4 cases. So A is 5, B is 5, A is 5, B is negative 5, A is negative 5, B is 5, and A is negative 5, B is negative 5. So totally in all, how many elements we got? We expected to find the number of elements. We got 4 plus 4, and that would be totally 12 elements. So the solution. So in conclusion, this would mean the number of elements in A is equal to 12. So that would be the final solution for this beautiful question. Welcome everybody. We got a question. It's a beautiful question, and let us get started. So the question is as follows. If the difference between the number of subsets of sets A and B is 120, then choose the correct options, right? So option A is the maximum of n of A intersection B is equal to 3. Option B, the minimum of n of A intersection B is equal to 0. Option C, the max of n of A union B is equal to 21. Option D, the min of n of A union B is equal to 7. So max of n means we are talking about the maximum value. Min of n of A intersection B means we are talking about the minimum value, right? So have that in mind. Now foremost, this is the solution. Let me start the solution. Now we are talking about subsets of the set A and B. So I'm going to start up like this. Let A and B be the respective sets. So this means from the question, it's given in the question, right? So from the question, n of A, B equal to m, and n of B equal to n. Therefore, the total number of elements from A and B, so it says the number of subsets of A and B, the difference is 120. So this means the number of subsets of A. So when I say n of A, number of elements in A. When I say n of B is equal to n, it means number of elements in B. So number of subsets of A is going to be 2 raised to the power of m, and number of subsets of B is going to be 2 raised to the power of n. Okay, given, what is given? The difference between these two is equal to 120. Now what I wish to do from here is I would like to take 2 raised to the power of n out. So that would give me 2 raised to the power of m divided by 2 raised to the power of n negative 1 is equal to 120. Now this can be further rewritten as 2 raised to the power of n times 2 raised to the power of m negative n. Negative 1 is equal to 120. Now I can write 120 as 8 multiplied with 15. 8 5s are 40 times 8 1s are 8 plus 4 gives me 120. Right? So this is 2 raised to the power of n times 2 raised to the power of m negative n negative 1. Now this can be further rewritten as 2 raised to the power of n times 2 raised to the power of m negative n minus 1. Now 8 can be written as 2 raised to the power of 3 times 15, right? Now I can equate these two together. So this means 2 raised to the power of n is equal to 2 raised to the power of 3. So n is equal to 3. Okay, also you got 2 raised to the power of m negative n. Negative 1 is equal to 15. You push this one to the other side. So 2 raised to the power of m negative n is equal to 16. Now I can write this as 2 raised to the power of m negative n is equal to 16. I write it as 4 squared. This can be further rewritten as 2 raised to the power of m negative n is equal to 4. I'm going to write it as 2 squared. This is raised to the power of 2. So this means 2 raised to the power of m negative n is equal to 2 raised to the power of 4. So this would mean m negative n is equal to 4. But my value of n is 3. So therefore m is equal to 7. So I've got a value for m. I've got a value for n. But the question wants us to find the minimum values, right? So this means n of A is equal to 7 and n of B is equal to 3. We are expected to find the minimum value and the maximum value. So we want to know what is the max of n of A intersecting B and the minimum of n of A intersecting B. So now what is the value for A intersecting B? Now let me write that down here. Now clearly we know A has got m elements. M is equal to 7, right? Now let me write down those 7 elements. A1, A2, A3, A4, A5, A6, A7. Now B has got 3 elements. So let me write those 3 elements, A1, A2 and A3. Now what would be the intersection? Now if you were to take the intersection, this is going to be the intersection, right? How many elements are there? Therefore n of A intersecting B, the maximum number of values that can be in the intersection is what? Is 3. So this is the maximum value, and the minimum value will be equal to 0. So in other words, it can have an intersection. If it has an intersection, the maximum is 3. It need not have an intersection. If it doesn't have an intersection, its minimum value would be 0. So the value is going to be 0 less than equal to n of A intersecting B less than equal to 3. So this is the minimum, this is the maximum. So I can clearly write that down here. The maximum is 3, the minimum is 0. Okay, so go up to the choices. What are the choices? The maximum is 3, that's fine. the minimum is 0. This is also correct. So this is the right choice, this is the right choice. Now maximum of n of A union B. So you have to find A union B is 21. Now let's find that out. Let's get that out. Now how do we find that out? Now there is a very important formula. N of A union B is equal to n of A plus n of B negative n of A intersection B, right? Now what is this? This is 7, this is 3, 10, negative. This has got a minimum value of 0 and a maximum value of 3. So let me just check that out. So this is equal to 7 plus 3 is 10. Now when it takes the least value, that's 0, then n of A union B will hit a maximum. That's going to be 10. Now when it takes 3, n of A union B will get a minimum value. That's going to be 7. So the minimum, let me write that down, min and max. So max is 10, min is 7. So let's check that out. Max is 21, it's given. So this is not a choice. This is not a choice. Min is min of A union B is 7. This is a choice. Can you believe that? So the right choices are A, B, and D. You see that? See the way they're asking the question. So it's not just one choice, but 3 of these things are actually the correct choices for this question. You can pause this video and do this question. Students, the question is as follows. Given A and B are 2 sets, the set A has 2016 more subsets than B. If A intersecting B is equal to 3, find n, or let me just state it like this, find the number of elements in A union B, right? Now whenever they're asking you this question, you need to use this formula. So we know that they're asking us to get the number of elements. So n of A union B is equal to n of A plus n of B negative n of A intersecting B. This is a formula we will have to utilize. So based on this formula, we will go about doing the question. So from the problem, we know that, what do we know? The number of elements, if, or I should say the subsets of A is greater than the subsets of B by 2016. Okay, so from the problem we know that n of A is equal to m and n of B is equal to n, and 2 raised to the power of m negative 2 raised to the power of n is equal to 2016. Of course you might be asking me, wow, is it given? M and n are not given, so why are you taking it? You have to understand that there are information or data within the question that would not be explicitly stated. Now it is your responsibility to extract those unseen information. So that's exactly what I'm showing you here. Now if you were to take n out, or 2 raised to the power of n out, this can be rewritten as 2 raised to the power of m negative n negative 1 is equal to 2016. I want to disintegrate 2016 using 2, right? Now 2 divides here 1 time, 0 time, 0 time, and 8 times, and then 2 again divides here 5 times, 0 times, 4 times. You need to do this. 2 again divides 504, 2 times, 5 times, 2 times, 2 again divides 252, 1 time, 2 times, 6 times, 2 again divides this 6 times and 3 times, and then you can just take it as 63, you don't have to worry. So 2 raised to the power of 5 multiplied with 63, this is what you've got. So I can equate these two together. So this would mean 2 raised to the power of n is equal to 2 raised to the power of 5. So this means n is equal to 5. So you've got that value. Now also 2 raised to the power of m negative n is equal to 63 plus 1, which means 2 raised to the power of m negative n is equal to 64. 64 means 2 power 6. I'm using the space. So this would mean m negative n is equal to 6, and n is already 5, so m will be equal to 11. So I've got the value for m as well as for n. Now we need to extract n of a in b. So I'm taking this as 1. So therefore using 1 we get, so what do we get? We get n of a is given to be as m, so that's going to be 11. So 11 positive 5 negative n of a intersecting b, that's given as 3. You see that? Substitute that. So over here you got 16 negative 3, which is going to give you 13. So therefore n of a union b is equal to 13. So if you were to be given the choices, right, say a is equal to 10, b is equal to 11, c is equal to 13, d is equal to say 15, your choice in this case should be 30. So this is a lovely question, and there is a high likelihood of such questions appearing in your exams, specifically for competitive entrances. Okay, so we got a next question. We are expected to obtain the symmetric difference between A and B. So the most important point that we need to focus is symmetric difference. What exactly is symmetric difference between two sets? Now the question is given as follows. Given that A is equal to 1, 2, 3, 4, 5 and B is equal to 2, 4, 5, 6, 7 and 8, and the universal set is given as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now we are expected to obtain the symmetric difference. Now symmetric difference is represented by delta. A delta B is equal to, now they won't give you this formula, right? So it is your responsibility to have this formula in your mind. So A symmetric difference B is equal to A difference B union B difference A. So this is the all important formula that you will have to know. So let us find A difference B. So therefore what is A difference B? From A you take away B. So from A I take away B. So I need to take away this. 2 is out, 4 is out, and then 5 is out, right? Because 2, 4, 5 are present in A. So from A you take away B. So this is going to be 1, 3, 5, right? So this is what we have got for A difference B. Now B difference A. Now B difference A is from B 2, 4, 5, 6, 7, 8. You take away A 1, 2, 3, 4 and 5. So what would that be? So 2 is there, 2 is done. 3 no, 4 take away 4, 5 take away 5. So what elements have you got that is left in B? So that is going to be B difference A. So we got 6, 7 and 8. So therefore symmetric difference A delta B is equal to A difference B union B difference A. A difference B is 1, 3, 5 union B difference A is 6, 7, 8. This is equal to 1, 3, 5, 6, 7, and 8. Right? So this is the final answer to the question. So have that in mind. Now the all important question is, how do you represent by means of a Venn diagram? That can be done. So draw A, this is A, and draw B, this is B. Now A difference B is this part, B difference A is this part. Now the joining of this part with this part is what is called as A delta B. Of course, you need to put these things into a box, and this is the universal set. Right? Now this is the intersection. This part is going to be A intersecting B. Okay, after I have presented this question, you have got 30 seconds to answer this question. So the question is as follows. In a school, there are 3 games to be played. Some of the students, STDS, play 2 games or 2 types of games, but none play all of the 3 games. Which Venn diagram justifies the statement? So I'm going to draw 3 Venn diagrams. This is the first one. This is P. And this is the second one. And this is Q. And this is the third one. R. So you got the choices here. Choice A, P and Q. Choice B, P and R. Choice C, none. And choice D, Q and R. Your time starts now. Okay, let me give you the solution. If you got the answer, you can place it in the comment and I will give you a heart. In a school there are 3 games to be played. Some of the students play 2 games, but none, this is the catchword, none play all of the 3 games. So there isn't any common intersection for all the 3 circles. Now in this case there is an intersection, a common intersection. You see that circle 1, circle 2 is actually present in circle 3. So P cannot be taken. Now between Q, you got circle 1 intersecting with circle 2, fine, and circle 2 is intersecting with circle 3, but circle 3 is also intersecting with circle 1. You see that? This is the intersection. So Q cannot be also taken into account. Now you have a huge circle and 2 other circles intersecting, but their intersection is actually present in the larger circle. So R cannot also form a right choice. So the exact choice in this case is C. So this is the solution for this question. You got 30 seconds to answer this question. Students, the question is as follows. Which of the following choices represents the shaded portion, right? So you have a Venn diagram here, and a Venn diagram here, and this is the shaded portion. Right? So you have the following choices. Is it A intersection of B union C? Is it A union of B intersecting C? Is it A intersection of B difference C? Or is it A difference of B union C? Come on, you have 30 seconds. Which of these choices do you think is the right choice that represents the shaded portion? Okay, so I hope you all have got the answer. Now what is B union C? This entire region is B union C, right? B union C is this entire region, two circles. So we are taking B union C out of A, right? This part is being taken out. So option D is the right choice. We got a beautiful question here. Let me write that down. If A is equal to all x element of real number such that modulus of x negative 2 is greater than 1, and the B is collection of all x element of R such that square root of x squared negative 3 is greater than 1, and C is collection of all x. You can also write it like this, such that x is element of R and modulus of x negative 4 is greater than or equal to 2. So you can also specify more expressively like this, right? And Z be the set of all integers, right? Then find the number of subsets of the set A intersecting B intersecting C complement intersecting with Z. Now this is a beautiful question, and we need to do a lot of things to extract the value for this question, right? They're asking us to obtain number of subsets. So this is the catch point. They're not asking us to get the number of elements. They want us to get the number of subsets of this particular set. So we will have to get that set. Now foremost, let us write the set. This is a solution. Set A is all x such that x is element of R, and you got modulus of x negative 2 is greater than 1. Now consider, I want to write the elements for A. For that, consider modulus of x negative 2 which is greater than 1. Now this is greater than 1. That would mean there are two probabilities. One is x minus 2 is greater than 1. The other one is x minus 2 is less than negative 1. So solving these two would extract the value for x. So from here, x is greater than 1, push this 2 to the other side. That would give us a positive 2. So x is greater than 3. Push this negative 2 to the other side. That would give me x is less than negative 1 positive 2. So in this case x is less than positive 1. So you got two values, x less than negative 1, x greater than 3. So if you were to write that on the number line, you got 0 here, and then you got 1, 2, 3, and you got values starting from this point. So from 1, all values to its left, and from, you need to have the circle, so don't shade it up. If you shade it, it is incorrect. So from 3, all these values that are going, so these are the values of x. So therefore, if you are going to be writing the set A, so what is A? A is all values from negative infinity to 1, and then all values from 3 to positive infinity. So this is the set A. Now we have got the set A. Now let us go and get the set B. B is given to be as all x element of R such that root of x squared negative 3 is greater than 1. Now let me state that set all x such that x is element of R and square root of x squared negative 3 is greater than 1. This is what we have been given. Now to get the function, this is the function, so let me consider square root of x squared negative 3 greater than 1. I square both sides. Let me write that down. Squaring both sides, we get, so what do we get? This is going to be x squared negative 3. The square and the root gets cancelled. This is greater than 1. Now as I mentioned to you, x squared negative 3 is greater than 1. What you can do is to solve this, push this one to the other side. So this would mean you got x squared negative 3 negative 1 is greater than 0. This means x squared negative 4 is greater than 0. This means x negative 2 times x positive 2 is greater than 0. So this is what you have got. Now if you were to plot this, right, let me just plot this. This is positive 2 negative 2. So 0 1 positive 2 minus 1 minus 2. So strictly greater than. So this is going to be from here positive 2, it goes up, and over here negative 2, it goes this way, right? But this is not the final answer for the set. We are actually extracting the elements. In that case, we should also look into the domain. Now this x squared negative 3 is present inside the square root. So that would mean this is the next step. Now this is possible. The set B is possible because, why am I talking about the value inside the square root? Because for set B to be alive, this should not perish, right? That's the reason I'm stating here. The set B is possible if and only if the value inside the square root should be greater than or equal to 0. 0 is okay to start with. That can be the minimum value. But from there onwards, it should be towards the positive side. It should be greater than or equal to 0. Because we are not talking about complex values. We are only talking about real quantities. So x squared negative 3 should be greater than or equal to 0. So what does this mean? This means if I were to rewrite it, this is going to be x negative root 3 times x positive root 3. This is greater than or equal to 0. So if I were to plot this, now root 3 is 1.7321. So 1.7321 negative side is going to be somewhere over here, right? Greater than or equal to. So it's a shaded point. And positive 1.732 is going to be closer than this. It's going to be this. Since it's greater than, I'm shading these two parts. So if you were to draw the line, this is going to be like this on this side, and this is going to be like this. So we are looking for the intersection. So the intersection value for this is actually going to be starting from this particular point, right? So this is actually a hole. So there is not going to be any intersection. So set B is going to be equal to from infinity to negative 2 union from this particular point, this is not going to have an intersection because it's a hole, so the intersection will actually start from this end. So if you were to shade this, this is going to be the intersecting part and this is going to be the intersecting part, right? So from 2 to positive infinity, so that is going to be the set for B. Okay, fine, we got the set for B, and now we need to get the set for C. Now what is C? Let me show you what is C. X greater x negative 4, modulus of x negative 4 is greater than or equal to negative 2. So let me write that collection of all x such that x is element of R and that modulus of x negative 4 is greater than or equal to 2. So this would mean x negative 4. So if you were to consider, let me write that down, consider modulus of x negative 4 is greater than or equal to 2. So this would mean x negative 4 is strictly greater than 2 or x negative 4 is less than negative 2. If you were to push this 4 to the other side, you get x is greater than 2 positive 4. So x is greater than 6. In this case, if you were to push this 4, x is less than negative 2 positive 4. That's going to be x less than 2. So you got x less than 2 and x greater than 6. So two such values you have got, right? X greater than 6 and x less than 2. So if you were to plot this, let me just show you how it looks. So this is going to be 0, 1, 2, 3, 4, 5 and 6, negative 1, negative 2, negative 3, negative 4. So less than 2, less than 2. By the way, it is imperative to observe this. This is greater than or equal to. So we need to change that, right? So this is going to be the value, right? Greater than, so x is greater than 6. So from 6, it's a color, shade the entire thing and it moves like this, and then x less than 2. So from less than or equal to 2. So from here, this goes. So if you were to write this, this is going to be negative infinity all the way to 2 union 6 all the way to infinity, right? And what is this? This is nothing but my value of C. Now we need to obtain the intersection of all these sets. So let me go up over here. I've got a space, a beautiful space reserved. Let me write down the set B. Now B is this. So negative infinity, negative 2 union 2 comma infinity, and C is negative infinity to 2 union 6 to infinity. Now we would be able to obtain the intersection only by means of the number lines help. So I'm drawing this line. Now let me just place in the values. So this is 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5. Now from 1, let's check it out. From 1 to negative infinity, union from 3 to positive infinity, it's open, and then from negative 2 all the way to negative infinity, and then from positive 2 all the way to positive infinity, and then from positive 2, so from positive 2, okay, this is positive 2, so from positive 2 all the way to negative infinity, and positive 6 to infinity. So these two are shaded, right? So where exactly do we have the complete intersection? So we will have to look into the complete intersection that is taking place. So if you were to see that complete intersection would only occur at this particular point. So that's going to be negative infinity to negative 2, and we are having complete intersection from this particular point. Right, so I can state here, so what is A intersecting B intersecting C is negative infinity to all the way to negative 2, and then union close interval 6 to infinity, so 6 to infinity. So this is what we have got, but we don't need this. This is not needed. What is needed? We are expected to find A intersecting B intersecting C complement. That's what is needed. You see that? Now how do you get that? I will give you a trick. Whatever that is not present here should be included here, right? So over here we are stopping with negative 2, right? Because this is covering all the way from negative infinity to negative 2, so that's open interval, and here we starting from 6. So there is a region, if you can see that there is a region here. So we are actually stopping till here, so we are not including negative 2, right? So there is a region which is actually starting from negative 2 and going up all the way to 6, but apparently 6 is actually shaded here, but we need not have to touch 6. In other words, we need to just go close to 6 by not including 6. So that would be this point, this open region. So from here to here would be the intersection, because this is what is not featuring, right? So write that down. So what is going to be placed here is negative 2 comma 6. Now with regard to the intervals, or I would say with regard to the parentheses, let me give you this trick. Now you see open, right? So you put a close. You see a close here, right? You put a open. Whatever you see here, revert it. This is open, place close there. This is closed, place open there. So negative 2 comma 6 is going to be A intersection B intersection C complement, but we have to intersect it with the Z, right? So let me do that here, intersecting the quantity with Z. So A intersection B intersection C complement with Z. Now what is this set? Let me write the set. This set is actually starting from negative 2 to 6. So negative 2, negative 1, 0, 1, 2, 3, 4, 5. No, 6 is not included. And set of integers. What exactly is the set of integers? The set of integers are actually starting from negative infinity. It goes all the way to negative 2, etc. You have a dot here, etc. Negative 1. And then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. to positive infinity. So negative infinity to positive infinity. So where do you get the intersection? The intersection is only found with these points: negative 2, negative 2, negative 1, negative 1, 0, 1, 2, 3, 4, 5. So what's the set? The set is going to be, let me write that down here. The set is going to be negative 2, negative 1, 0, 1, 2, 3, 4 and 5. That is going to be the set. But we need to obtain the set of all subsets. So 1, 2, 3, 4, 5, 6, 7, 8. So what is the set of all subsets? So let me write that down. Therefore, set of all subsets. How many elements are there? 2 raised to the power of 1, negative 2 to 5. It's going to be 8 elements. 3, 6, 7, 8. So 2 power 8. This is the answer. So students, this is a lovely question, and we have done that question in a lovely manner. We will move on to the next one. Let's do this question, students. We got 2 sets, A is collection of all x such that x is element of R, and you got modulus of x less than 2, and you got B, collection of all x such that x is element of real numbers, and modulus of x negative 2 is greater than or equal to 3. Now you will have to pick one of the choices. Choice A intersecting B is equal to negative 2 comma 1, negative 1. This is open parenthesis or open curl bracket. B negative A is equal to R minus negative 2 comma 5, and C is A union B, R negative 2 comma 5, and D is A minus B is negative 1 comma 2. So foremost, what we need to do is we need to extract the elements. So we're given modulus of x is less than 2. Okay, this is given. Since modulus of x is less than 2, this is nothing but negative 2 less than x less than 2. So all values of x for which you got negative 2 less than x less than 2. So this has to satisfy. So you can clearly write A be equal to, is open interval, negative 2 comma 2, because of the fact it's given that modulus of x is less than 2. Now let's go to B. You got modulus of x minus 2 is greater than or equal to 3. So let me write that down. Consider. So this would mean x minus 2 is greater than or equal to 3, or x minus 2 is less than or equal to negative 3. So from here you move this negative 2 to the other side. You get x less than or equal to negative 3 positive 2. So that would mean x is less than or equal to negative 1. Over here you move this negative 2 to the other side. You get x greater than or equal to 3 positive 2. So x greater than or equal to 5. 5 and negative 1. So how do we write this? So if you have to draw the number line, this is 0, 1, 2, 3, 4 and 5. This is negative 1, negative 2, negative 3. So negative 1 onwards and positive 5 onwards. So B is equal to negative infinity to negative 1 square parenthesis union square parenthesis 5 to infinity. Right, this is what you've got. Now the all important question is the choices. A intersecting B is negative 2 comma negative 1. Is it true or not? Now we need to find what is A intersection of B, because according to the choice, A intersection B is given as, let me write that down here. It is given to be as negative 2 comma negative 1. Everything is open. This is according to the choice number A. You can check it out. But I want to know whether this is what we are going to be getting. Now for that, what we need to do is we have to use the number line. So let me draw the number line. I'm going to first plot the points 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5. Now let me plot the points for B. Now the set B is negative infinity to negative 1 square parenthesis union square parenthesis 5 to infinity. So that would be starting from here, shade it, move it up, and negative 1, and you move it up. So negative 1, it's all closed. Now we will have to put in the value for A. Now what is A? A is actually between negative 2 and 2. This is the set A. So if I were to place it, so this is going to be open, this is going to be open, and this is the region, right, that we are talking about. So A intersection B, what would A intersection B be? So that would mean I have an intersection here, that's fine, and then I go all the way up to here. So A intersection B, -2 is open, but -1 is actually closed. This should be the value, but in the choice we're getting an open here, right? We're getting an open here. So choice A is not the right answer, so we drop choice A because of the fact that we have found this value. Okay, now let us go to the second one. The second one is, this is the first one. The second one is, the choice states that B negative A can be written as R negative of -2, 5. Is this true? We got to check that. So for that we need to extract B negative A. So what is B negative A? From B, take away everything that belongs to A. Now go to the diagram. This is B, this dark line is B. From B I take away everything that belongs to A. So A is from -2 to +2. So that means I can take away -1 all the way here, but when I come to -2, is it possible for me to take? This is open, right? This is a circle. If it is closed, then I can take away -2. So my B is going to be -∞. -2 cannot be taken, so it's still there in B, right? So -2, you place a closed interval, you can't place open interval, because -2 is not actually removed. So that would mean -2 is still intact with B, and then I unite this with all other elements that belongs to B. So that's going to be 5 to infinity. So this is what I've got. Now if I were to write this in terms of R, so that means from R I should take away things which are not present in B negative A, and that would means I'm looking for the other part which is not included, right? The complement of it. So if you take away from R the complement of this, that would subsequently give us B negative A. So what would that value be? So to get the value, we need to look at the intervals, right, which is actually not present here. So we clearly see the values from, or the values that are existing between -2 and 5. So if you were to go to the number line, -2 is present here. So we are looking at the values, closed interval -2 to 5. So we cannot take a closed interval, we have to go a little bit away from the closed interval. So that would mean we need the interval -2 to 5, but as I mentioned to you, you got a closed interval, you place an open interval here, you got a closed interval, you place an open interval here. So this would be the region which are not falling between, or which are not falling in the region of B negative A. So this region has to be subtracted from R, simple as that, and that would be a equivalent representation for B negative A. Now if you were to clearly see the choice, then this choice is present. Okay, this is actually choice B, so I can clearly take this choice. Now let me verify choice 3. Choice 3 says A union B is equal to R negative of 2, 5. This is what the choice states. So from R you take away 2, 5, and that would be A union B. But is it true? Is this true? we need to check. So what is A union B? Let me go up and find out what is A union B. A union B. Now my B is actually starting from here, -1, and moving up to -infinity, and my A is between -2 to +2. So that would mean I have let me write that down. So from -infinity, this is the region of A, all the way to 2, because we're talking about A union B. So all the way to 2, and then this has to be united with close interval 5 to +infinity. Now if you were to write it in terms of R, then this would mean R negative, you got to take the complement of this. So that would be going to be, you got a 2, let me write the 2 and a 5. This is open, so you place a closed. This is closed, so you place a open. Is it what we got? No, because in the choice this is given as open, and that's a problem. So this is dropped, this choice is dropped. So, and also the fourth choice. So the only choice for this question, the choice for this question is choice B. So that's the answer for this question. Welcome students, we got a beautiful question here. Let me write the question down. Let A be equal to all n element of natural numbers such that n squared is less than equal to n positive 10,000, and you got B, which is of the form 3k positive 1 such that k is element of natural number, and you have C, which is of the form 2 times k, where k is element of natural numbers. We are expected to find the sum of all elements in the set A intersection with B difference C. Right, this is required. Now foremost, let us write down the sets. So this is the solution. I'm going to start with B. Over here I'm going to show you the working. Now take the value for k is starting from 1, 2, 3, 4, 5, set of all natural numbers. So if I were to take the value for k is 1, this is going to be 3 times 1 positive 1. The first value is 4, 3 2s are 6, positive 1, 7, 3 3s are 9, positive 1 is going to be 10, and 4s are 16, 17, 5 3s are 15, and this is going to be 4 3s are 12, 13, right, and 5 3s are 15, positive 1, that's going to be 16 here. And when I take the value of 6, 6 3s are 18, positive 1, 19, I take the value 7, 7 3s are 21, 22, and so on and so forth. So that is the set for B. So I'm going to start the set for B. 4, 7, 10, 13, 16, 19, 22, etc. Now set C, k takes the value 1, 2, 3, 4, 5, 6, 7, and so on and so forth. When k is equal to 1, I get 2, k is equal to 2, I get 4, k is equal to 3, I get 6, k is equal to 4, I get 8, k is equal to 5, I get 10, 12, 14, 16, 18, so on and so forth, right? Now, foremost, let us consider, we are given, what are we given? We are given to find A intersection of B difference C. So let us consider B difference C. So what is B difference C? From B, 4, 7, 10, 13, 16, 19, 22, etc. From B, we have to take away C. 2, 4, 6, 8, 10, 12, etc. What is the meaning of this? It means from this set, take away all of these. So what are these? 2, 4, 6, 8, 10. Set of even numbers. You remove all the even numbers. So I will have to drop this, drop this, drop this, drop this, so on and so forth. So what would be the set? So therefore, B difference C is equal to 7, 13, 19, etc. This is going to be the difference. Now let us consider A. Let us consider the set A. What is A? All n such that n squared is less than equal to n positive 10,000. This is what is being given. Let me write that down. It has all n element of natural number such that n squared is less than equal to n positive 10,000. Now consider the restriction. N squared is less than equal to n positive 10,000. I can push this n to the other side. This is going to be n squared negative n less than equal to 10,000. I can rewrite this as n into n negative 1 less than equal to 10,000. I can write it as 100 multiplied with 100. So this means A has all n element of natural numbers such that this restriction has to be true. N of n negative 1 less than equal to 100 multiplied with 100. Right? Now this entire set has to perform the intersection with B negative C. So this means you have this particular set, all n element of natural numbers such that n into n negative 1 less than equal to 100 times 100 is actually carrying out an intersection with 7, 13, 19 and so on and so forth. Right? Now this 7, 13, 19, when it performs an intersection with this set, the only elements that would be carried out would be all those elements which are values of this, right? Because this is obviously the set that is intersecting with this. And not only that, when we say intersection, it means we are talking about elements which are common. So what we will do, the idea is to take out each element and try to see if they are satisfying this inequality, n times n negative 1 less than equal to 100 times 100. If it satisfies, then that element would fall into this parenthesis. So that is the idea. So we will have to look for all n, right? So let's do that. So when I take n is equal to 7, 7 into 7 minus 1 should be less than equal to 100 times 100. Is it true? 7 minus 1 is 6. 6 times 7 is 42. 42 is less than equal to 100 times 100. So this is true. So I can very well place 7 there. Now n is equal to 13. Substitute 13. 13 into 13 minus 1 is going to be 12. Now what is this? 13 times 12. 3 2s are 6. 2 1s are 2. 3 1s are 3. 1 6 5. 1 5 6. This is going to be true. It's obviously less than equal to 100 times 100. And you have to keep testing all these numbers. Clearly I know 19 will also be true. Now the last permittable number in this case is going to be, see, we got this relationship, n times n minus 1 is less than equal to 100 times 100, right? Now if I were to take the value for n to be equal to 100, then this is going to be 100 times 99, which is going to be true. 100 times 100, this is going to be true. But apparently if you were to go to the set, you can clearly see the first element is 7. You add 6, you get 13. You add 6, you get 19. You add 6, you get 25. but all of these numbers are actually odd numbers in nature. 100 is actually even in nature. So n is equal to 100 has to be ruled out. This is ruled out. N is equal to 101 cannot actually satisfy this inequality. So obviously n is equal to 100 is the last value that is satisfying this inequality. So having ruled out n is equal to 100, can I take n is equal to 99? Now if I were to take n is equal to 99, this is going to be 99 times 99 negative 1, right? That's going to be 98. So this is the value that we are actually obtaining here. But the question is 99 part of this set? That is the most important judgment that we need to take here, right? Now how do we get that judgment? Now that judgment can easily be obtained from this set of elements that we have got. Now 7, I can write 7 as 3 times 2 positive 1. I can write 13 as 3 times 3 positive 3 times 4. 3 fours are 12, right? Okay, I can write the element 13 as 3 times 4 positive 1. That's fine. So the next element is going to be 19. I can write 19 as this starts with 2, this starts with 4, and the next element is going to be 6. 3 times 6, 18 positive 1. That's fine. So the next element is going to be 25. So 25 can be written as 3 times of 8 positive 1. 8 3s are 24 positive 1. So I add 6, next element is going to be 31. 31 can be written as 3 times of 10 positive 1. Now let me go one more time. So the next element is going to be 37. 37 can be written as 3 times 12 positive 1. 3 times 12 is 36 positive 1 is 37. So clearly you can see I'm able to express the quantities 7, 13, 19, 25, 31, 37 as a product of 3 times a quantity. It doesn't matter what quantity I'm placing it here, but what matters is this particular pattern which I've got. So any number for that matter has to be some product times 3. Of course we are adding 1. So 99 times 98, I should be in a position to write it as 3 times some quantity positive 1. You follow me? I'm not much bothered about this 98. What is my concern is n is equal to 99. If n is equal to 99 has to be present here, then I should be in a position to write it in this fashion. So the only way I can do is that if I were to place 33 here, 3 times 33 is 99 positive 1, that would give me 100. But I don't need 100. I need to produce actually 99. Is it possible? Of course it's not going to be possible, because to bring 99 I need to have this pattern in place, but this pattern will just not produce 99, but it will produce 100. But I don't need 100, right? If I were to take n is equal to 100, this condition actually fails. The inequality will fail. So what is the next obvious number? N is equal to 98. Now if you were to take n is equal to 98, is it possible for me to write it as 3 times some quantity positive 1? So let me check it out. If I were to place here 30, that's 90. 32, that's 96. So 98 is also ruled out. Now is it possible for me to produce 97? That's a check you need to do. Now clearly you can see 97 is occurring. So 3 times, how is it possible? 3 times 32 positive 1 is giving me 97. So this is the last value that the set will hold. That in turn will be the appropriate value which when intersected with this set would produce me a completion. So that is the understanding that we draw here. So 7, 13, 19, etc. 97 will be the completed set formed out of the intersection of A with B difference C, right? So having got that, that doesn't complete the question. The question wants us to find, if you were to go up here, it wants us to find the sum of all elements that are present in the intersection. So we need to obtain the sum. Now how are we to obtain the sum? Now that sum can be obtained from here. Now clearly I can just proceed on like this. And then finally, I am hitting 97. I am actually writing 97 as 3 times 32 positive 1. So I need to count the total number of elements that are present here. How many elements do you think are present here? How many elements? Can you tell me how many elements are present here? Now to find the number of terms, let me use the space. We are going to be using this formula. Tn is equal to a plus n minus 1 into d. So this is the last term. What's the last term that you got? You got 97. So 97, the first term, what's the first term you got? 7 plus n minus 1. The common difference that you see here is 6. So move this. 97 minus 7 is equal to n minus 1 times 6. This is going to be 90 is equal to n minus 1 times 6. You divide by 6, you get 15 is equal to n minus 1. Therefore, n is equal to 16. So you got n is equal to 16. Now you need to find the sum of the elements. So let me just use the space. We are expected to find the sum of all the elements in 7, 13, 19, etc. 97. Let me use the space. So I will be using this formula. The formula is Sn is equal to n times the first term a plus the last term, and you have to divide by 2. That's the formula you need to use because the last term is known, the first term is known. So total number of terms is 16 divided by 2 times the first term is 7, the last term is 97, right? So 2 divides here 8 times. So you got 8 with 97 added with 7. 7 added with 7 is 14. You carry 1 and that becomes 10. So 104 times 8. Let me write the answer here. 8 times 4 is 32. 3. 8 ones are 8. So this is the final answer, 832. So if they give you this choice, your choice of selection should be 832. So that is the final solution for this question, and we will move on. This is a lovely question because it is asking us to apply the concepts which we have studied probably in grade 8 or grade 7, and that is a good thing. Always applying things that we have studied in the past is actually a very good thing. So let's move on to the next question. Students, in this particular section we will deal with questions connected in the application of set theory properties. Now, if you are having some doubts with regard to the properties of sets, I would like to request you all to see the lesson previous to this. So, having mentioned this, let me start off by giving you this question. If u be equal to all x such that x is element of natural number, and you got 2 less than equal to x less than equal to 12, you got a being equal to all x such that x is even prime, and you got b is equal to all x such that x is element of u, and x is a factor of 12. Which of these or which of the following is not true? Not true. So you have to make the choice which is not true. So the choices are given as follows. A difference B is empty. B, A difference B is equal to B intersecting A complement. choice C, A complement difference B complement is equal to B negative A, and choice D, A intersecting B the whole complement is equal to A complement union B complement. Foremost, we have to extract the elements. Now let me start off with U. All x such that x lies between 2 to 12. So my U is going to be starting from 2, 3, 4, 5, and it goes all the way to 12. And A is even prime. The only element which is even and prime is 2. So 2 is the lowest or the smallest prime. Apparently it is also an even number. So that is really a miracle. Now next is set B, all x element in U which is a factor of 12. So which is actually dividing 12. So 2 divides 12, 3 divides, 4 divides, 5 no, 6 yes, 7 no, 8 no, 9 no, 10 no, 11 no, but 12 also is a factor of itself. So this is what we've got, A and B. Is there anything else? No, we've got all of this. So this is actually written in rooster form, right? This is in rooster form. Now having got this, let us first check out the first choice. The first choice states A difference B. So from A, you take out B. Now B has got 2, A has got 2. If you were to remove that, what do you get? You get empty. So this choice is true. And we don't need this because it states only choose those choice which is not true. So this is true. So we drop this choice. Next, let us check A difference B. A difference B is already equal to empty. Now we are expected to obtain B intersection A complement. Now this is B. Now what is A complement? Let me write that A complement. A complement is nothing but all elements which are not in A. So our universal set starts from 2. So you write the element which are excluding this element 2. So it's going to be 4, 5, 6, 7, and it goes on all the way up to 12. Now we are expected to find the intersection of A complement with B. Now what is the element that is common here if I were to perform this intersection? That intersection would be, I can write that down here, right? That intersection is going to be 3, 4, no 5, 6, yes, and 7 no, etc. and so on and so forth it goes, and 12 will be the element, because after 6 you will have again an even number, 8, that will also fall in. But the moment you get one element, all right. Now in this case there is one particular thing I need to mention. The moment you get one element, then the condition is a failure, right? So this is actually false. So this condition is the one that we are looking for, not true. But just hold on, let us check this one. So this is the third condition, A complement difference B complement. So what is that? A complement is this. Now from this we have to take away B complement. So what is B complement? Let me check the B complement value. So B complement would be all elements which are not in B. So 2 is here, 3 is here, 4. So that's going to be 5, 6 will be there, 7, 8, 9, 10, 11. So this is going to be B complement, right? So from A you take away all this. So what would that be? I take away 5, I take away 5, I take away 7, I have to take away 8, 8 is done, 9 is done, 10 is done, 11 is done. So all of these things will be out, right? So what I've got here, I've got a 3, I got a 4, I've got a 6, 8 is gone, 9 is also gone, 10 is gone, 11 is gone, right? And apparently I will have one more, 12 is present there, so we are not taking out 12. So let us check it one more time. Okay, Now let us check B difference A. Now from B you take away A. So what do you get? If I were to take away A, I would have 3, 4, 6 and 12. So this is a true relationship. So we don't need this. We don't need this. We don't need this. This one is actually De Morgan's property. Right? So let me state that down. A intersecting B, the whole complement, is equal to A complement union B complement. This is the De Morgan's property. It will always be true. So the choice that we need to get here is, the choice is B, and that is the solution for this particular question. It's a lovely question. We move on to the next one. This is the next question on set properties. Students, let's do this. We are given that A, B, C are sets such that A intersecting B is a subset of C, and that it is not equal to an empty set. Now we are asked to find which of the following is not true. Which of the following choices is not true? So you have to pick up that which is not true. So I'm going to state it here. A, B intersecting C is not an empty set. B, if, this is an all important word, if A difference B is contained in C, then A is contained in C. Now choice C, C union A intersecting with C union B is equal to C, and choice D, if A difference C is contained in B, then A is contained in B. So all of these choices are very confusing, but we can ensure that our understanding of sets will help us to zero in the right choice. Now the best way to solve this question is to make use of this particular property. A intersecting B is contained in C, and we will be using Venn diagram to answer this question. So we will add to given all possibilities that satisfies this property. A intersecting B is a subset of C. So let us use Venn diagram. Using Venn diagram to place in all possibilities. Of what? A intersecting B is contained in C. That is my objective. So the first one is A, this is set A is intersecting set B, and that has to be contained in set C. So this is okay. So this is case 1, right? That intersection is over here. It's present in C. This is C. Next, A is intersecting B. Now this intersecting part should be present in C. So let me draw that portion. So this is case 2. Case 2. Now A is intersecting B, and I can have this intersecting part on this end. Right? This is the intersection. This is the intersection. Now this is case 1, case 2, case 3. I can also have one more case. A is intersecting B, and that intersection is present in C. This is A, B, and C. This intersection is present in C. Now we can also have one more case where, in fact, two more cases we can have. but apparently I don't want to specify those cases. But for now, it is sufficient that we can answer the question using these three cases itself. Okay, using these three cases, or I should say the four cases that we have presented here, are more than enough. Okay, let's come to the first choice. B intersecting C is not empty. Let us just go up and check it out. B intersecting C, definitely in this case B intersecting C is not empty. There is an intersection. And B intersecting C is not empty. There is an intersection. B intersecting C is not empty. B intersecting C is not empty. So this choice is true. Okay, choice A is true. Now A difference B is a subset of C. This is a choice which has a condition. If A difference B is a subset of C, then A is a subset of C. So we need to do some thinking in that case. Now note this point. If A difference B is a subset of C. Now over here, from A you take away B. Clearly A difference B is a subset of C. And then when this happens, they are saying the claim is A is a subset of C. Clearly A is a subset of C. That is true. So when this condition holds good, it means A should be a subset of C. So this is true in this case. Now if I were to take away from A, if I were to take away B, and clearly I see that A is a subset of C. When when that difference is a subset of C, clearly I see that A is contained in C. Right? A is contained in C. This is C. A is contained in C. So the condition is true. Now come over here. Now from A you take away B. From A you take away B. But there is a part which is lying outside. Right? There is a part which is lying outside of C. So in this case the condition is actually failing us. Since this condition is a failure, we cannot proceed further. Right? So the same case happens here. So in situations where the case is true, when the condition is true, the subsequent follow-up is also true. So this statement is also going to be true. So I can just state that there. B is also going to be true. That's fine. Now coming to the next one, coming to this one, C. Now what is C? Now let me write that choice C. C is C union A intersecting C union B. This is equal to C is a claim. Now you got a C common, you got a C common. Can I write this as a property by taking C out? Can we do that? That's a question. So can I write this as C union A intersecting B? Is it possible for us to do that? That's nothing but distribution, right? So let me do that, right? C union A intersecting B. So this is nothing but distributive property. So C union A intersection C union B, right? But what is A intersecting B? Now let's go over here. A intersecting B is nothing but contained in C. So this is equal to C union C. What is C union C? You're going to get again C, right? So that is exactly what is represented here. So this is also true. This is also true. So we have left with one last property. Now let's write that property. Now what is that property? If A difference C, if it is contained in B, then A is contained in B. Now this is where I was just mentioning that there is another case that could also be placed here. Now let me write that down. Now this is A intersecting B. Now if I were to take A is equal to C, now let me draw that. Now A is equal to C is over here. It's exactly on A, right? Now we are performing from A you're taking away C. So from A, you're taking away C. So what is this? You will have nothing, empty. But empty set is a subset of B. This is true. Now, the claim is if this happens, then they are saying A should be present in B. Is it true? Just check it out. There are always elements in A which are not in B. There is only this part. If A is intersecting B, this is the only part that is performing the intersection. But there are other elements in A which are not in B. So A being subset of B is false. This is a false statement. So this means D is the right choice. D is the correct choice. So that is the end of this particular question. It's a beautiful question. Students, in this class we will learn about cardinality of sets. Now when you see this word cardinality, it means you are connected, or you are basically concerned with the number of elements a set has. So that's exactly what we are going to study here. Now there is a question which I would like to give you. The question is as follows: in a certain town, 25% of the families own a cell phone. 15% of the families own a scooter. 65% own nothing, neither a cell phone nor scooter, right? Because these two things are the products which you are focusing on. Now it's also given that if 1500 families own both a cell phone and scooter, find the number of families in the village or in the town, right? So this is a problem which can easily be solved. You're being given choices. Let me state the choice. 10,000, choice B 20,000, choice C 30,000, choice D 40,000, right? So you have to pick the choices. Now what I wish to do is I will use Venn diagram. Now let me just assume X to be the number of families that own both the scooter and cell phone. This is in percentage, right? So let me draw the Venn diagram. Now this is going to be families which are owning a cell phone. So let me just write here or use this color. Families which are owning a cell phone, and families which are owning a scooter, and families which owns a scooter and cell phone to be X. This is percentage. Now from X, or I should say, if I were to remove X from that percentage of families which are owning this set, right, owning cell phone, then that would be 25 negative X. So from this entire set, if I were to take away all x, that would mean I would have a region which are exclusively owning cell phones alone, right? Now similarly from scooter, it says 15% families are owning scooter. To get 15% from this set, I have to take away x, right? That's fine. So let me put this in a box and place the universal set. The universal set is what? In a town, 25% families own cell phone, 15% are owning scooter, 65% they own nothing. This is 65% of the people. So all of these people would comprise 100% of the town's population. So that's what we are going to do. So let me just add 65 with 25 negative x, positive x, positive 15 negative x. All of these are in percentage. This would account to 100% of the town's population, right? So I've got a positive x and a negative x that can be cancelled. I've got 25 added with 15, that's 30, 40. 40 added with 65, that's 105. I got a negative x. I throw the negative x to the other side. I bring 100 here. So that would mean my x is what? 5%. So 5% of the population in the town are owning both the cell phone and the scooter. And what is that 5%? That 5% is given to be as 1500 families. Now we need to get 100%, right? We need to find out the number of families in the village. So only 5% is being given, but we are worried about the other 95%, and that put together would give us the total families in the village. Now to get that, multiply 5 by 10, so you get 50%. You multiply this quantity by 10, so that's going to be 15000. 50% is 15,000. So therefore 100% is what? 30,000, right? And what is the choice? The choice is C. This is the choice, right? I hope you enjoyed this question. Students, let's move on to the next one. This is a very important formula you will have to know. So I'm going to give that formula to you. Given three sets A, B, C, and the sets are displayed as follows, right? And you are interested in, imagine this is A, this is B, and this is C. You have a complete intersection here. All the three sets are intersecting. Now if you are asked this question, find the number of elements in exactly two sets you're given A, B, and C, then you are actually looking at this portion, right? So that portion can be obtained by this formula, and that formula is n of A intersecting B positive n of B intersecting C positive n of C intersecting A negative 3 times n of A intersecting B intersecting C. So this is the all-important formula that we will be using to find the number of elements in exactly two sets when we are given A, B, and C, and there is an intersection taking place among these three sets. Now there is another formula that I wish to give you all. Find the number of elements in at least one set You're given A, B, C, and they are actually having an intersection among themselves. Now, this is the formula which we would have to use if the requirement is to find the number of elements in at least one set. That would mean it can be more than one set, right? So the formula is n of A plus n of B plus n of C, negative n of A intersecting B, negative n of B intersecting C, negative n of C intersecting A, plus n of A intersecting B intersecting C. So that is the formula which we would use. So we got the next formula, and in this case it's going to be find the number of elements in at least two of the sets, and we are given A, B, C such that you got an intersection happening among them. So this is going to be A, this is B, and this is C, right? So the formula for that is going to be n of A intersecting B plus n of B intersecting C plus n of C intersecting A negative 2 times n of A intersecting B intersecting C. So the all important word here is at least 2, right? So that should be the catch here. Now you got the fourth formula. The fourth formula is find the number of elements in exactly one of the sets. Now we started with 2 of the sets, and now we are reaching one of the sets. The sets are A, B, C, and that there is an intersection that is occurring. So this is A, this is B, this is C. And the required formula is n of A plus n of B plus n of C negative 2 times n of A intersecting B negative 2 times n of B intersecting C negative 2 times n of A intersecting C plus 3 times n of A intersecting B intersecting C. Okay, so let me draw a line. So these are all important formulae. Now to demonstrate this particular formula, I will be giving you this question. The question is as follows. In a class, there are 200 students in which 120 take math, 90 take physics, 60 take chemistry, 50 take math and physics, 50 take math and chemistry, 43 take physics and chemistry, and 38 take math, physics and chemistry. Now you are expected to find the number of students who take, or okay, let me write it like this, who take exactly exactly one subject. Now you have to understand, now they have given you 120 take math. It doesn't mean 120 students take only math, right? It also states here 90 take physics. It doesn't mean they only take physics. If they do not use that word only, then it means they would be taking math and some other subject also. We don't know. Now this is actually data which is widely distributed among the three subjects, and we are expected to find the number of students who are taking exactly one subject. So the keyword, the main focus is exactly, and that is where we need to use this formula. You see this formula? Find the number of students, or I should say find the number of elements in exactly one of the set. So this is the keyword, exactly. So what I would do is I will list out the informations that. So let's start the solution for this question, students. Almost what I wish to do is I would like to write down the data. Now you got number of students taking math to be as 120, number of students who are taking physics to be as 90, chemistry 60, who take math and physics is 50, who take math and chemistry to be 50, who take physics and chemistry to be 43, and people who take math, physics and chemistry is 38. This is the data that's been given. We expected to find number of students who take exactly one subject. So this is the keyword. That's the reason we will be utilizing the formula which I've just mentioned to you. So the formula that we would be using here is n of math plus n of physics plus n of chemistry minus 2 times of n of math with physics plus n of math with chemistry plus n of physics with chemistry, followed by positive 3 times of the complete intersection of math, physics and chemistry. So this is the formula we will be employing. Now just substitute the data. Number of students who take math 120, physics 90, chemistry 60, negative 2 times 50 plus 50 plus 43 plus 3 times of people who take all these 3 subjects is 38. Now this is 120, right? So 120 added with 90, that would give me 210 plus 60, that's going to be 270, negative 100, 143 plus 8 3s are 24, 2 3 3s are 9, 10, 11. So I'm going to add this with this, and that would give me a 4 and a 8 and a 3, negative 2 times 3 is 6, 4 times 2, 2 times 4 is 8 and a 2. So you have 384 and 286, 10, 8, you have a 7, that's going to be 9. So solution is 98. So this is the final answer. Total number of students who take exactly one subject, and that is a nice way for us to move on to the next question. So this is the next question, students. 2 newspapers, A and B, are published in a city. It is known that 25% of the city's population reads newspaper A and 20% read B, newspaper B. Now, of the 25% of the city population that reads A, 8% reads, now in this case it's not of the 25%, it is, it should be phrased like this. 8% reads both A and B, right? So this is not from the 25%, it just states that this 8% will actually be part of 25% as well as the 20% because they read both. So let's move on. Further, 30% of those who read A but not B, look into the ads. Look into the ads. Followed by 40% of those who read B but not A, look into the ads, right? While 50% of those who read A and B look into the ads. Now the question comes, find the percentage of the population who look into the ads. So that's the question. Okay, so the solution is got using Venn diagrams. So let me draw A and B. This is A, this is B, and it states that 8% read both A and B. So this is 8. So from 25 you take away 8, you get 17, and then from 20 you take away 8, you get 12. So 17 plus 8 will give you people who are reading A 25%, and 8 plus 12 will give you 20, the people who are reading B. So you just put this in the box, right? Next comes further 30% of the people who read A but not B. So we are talking about this region, 30% of this, right? So we need to get 30% of the people. So this is 30%, right? Now 30% of A but not B, look into the ads. So we need to get that. So this should be 30% of 17, right? People who read A but not B. So this is going to be 30 divided by 100 of 17. So I cancel this and this. 3 times 17, 7 3s are 21, 2, 51 divided by 10 is equal to 5.1%. So let me place that one, 5.1%. And next is 30, okay, that's done. Look into ads. 40% of those who read B but not A, look into ads. So 40% of those who read B but not A. So this is the region, right? We are looking into this region. We have already seen this region is already completed. So over here 40% of 12, and that is equal to 40 divided by 100 of 12. 0, 0 gets cancelled. 2 divides here 5 times. 2 divides here 6 times. 6 times 4, 24. 24 divided by 5. So how much is that? 5 4s are 20. And you get 4.8. So this is 4.8 percentage. So that's fine. Now the next comes 50 percentage of those who read A and B look into add. So 50 percentage of 8. So that's going to be 50 divided by 100 of 8. 0, 5, 2 divides here 4, which is equal to 4. So this is nothing but 4 percentage. So if you were to add, it says find the percentage of the population who look into the add. So that find the total net. So total net is received by adding this 8 1 8 2, that's going to give me 9, 4 plus 4 8, and that has to be added with another 5%. That's going to be, so that's going to be 13.9. So let me complete it. So the solution is 13.9 percentage. Let's move on to the next question. Now in this section we will be looking into questions dealing with the maximum and minimum value of A intersection B. Now there are a few important relations you will have to know in this case. Always remember the total number of elements present in A union B will be less than equal to the total number of elements present in the universal set. Now, property or relationship number 2 is n of A plus n of B negative n of A union B, or I should say A intersecting B, is always less than n of universal set. And number 3 is that n of A plus n of B negative n of U is less than equal to n of A intersecting B. So this is also an important property. Now the next one is, this is an interesting property. The total number of elements n of A intersecting B will always be less than equal to the minimum of n of A and n of B. Let's do this question, students. We got an interesting one. Survey shows that 63% of the population in a city read newspaper A. 76% read newspaper B. If X percentage read both A and B, find a possible, only one value they are asking, a possible value for X, right? This is what is required. Now what we are going to do is we are going to give the choices. The choices are given as 29, 37, 65, and D is 55. So these are the choices that are being given. Now 63%, 76%. So let us just add them, 63 percentage, 76 percentage, and from that actually we are using this formula. We have to take away x. Clearly that is going to be less than equal to. Now whenever we are talking about percentage, we have to use 100, right? This is 63 percentage and this is 76 percentage. From that we are taking away x percentage, and that's going to be less than equal to 100. So this is the universal property. Now if I were to add this 63 and 76, that's going to give me 9 and 13, negative x less than equal to 100. If I were to move 100 this side and x that side, I would get, I'm using this part, I would get 39 less than equal to x. So this is one relationship that we have obtained, but we need to obtain the bound for x, right? So x is clearly greater than equal to 39, but what is the bound? Now whenever you're talking about bound, you see that you have to use this property, n of a intersecting b. X is nothing but a intersecting b, right? Because x percentage read both a and b, and that bound would be the minimum of the number of elements in a followed by the number of elements in b. So we have here 63 and 76. So what's the minimum of 63 and 76? 63. So this is the value for x that we have to look for. Now go back to the choices. Find out that choice which falls in this range. The value of x lies between 39 and 63. So of that value, this has to be dropped, this has to be dropped, and this has to be dropped. The only choice is D. Choice D is the correct answer to this question. Let's do this question, students. A survey shows 73 percentage of the persons in an office like tea, 65 percentage like coffee. Now x, let me write that like this, if x percentage, the number, or I would say the percentage, x percent, if x denotes the percentage of people who like both, then find the value of x that cannot be. So we are looking for the value of x which is not possible, right? So we are being given choices: A 63, B 36, C 54, D is 38. So now we will be using the property which I just mentioned here. So people who like tea, n of tea plus n of coffee, negative n of tea intersecting coffee is less than equal to n of the universal set. 73 percentage positive, 65 percentage negative x is less than equal to 100. This is going to give me 8 and 138, negative x less than equal to 100. This can be rewritten as 138 negative 100 less than equal to x. So that means 38 is less than equal to x, but this is going to have a bound of the minimum value of a and b, right? In other words, the minimum values present in tea and coffee. So the minimum have to be chosen here. So 73 and 65, the minimum is 73 and 65, minimum is 65. So this is the value. So x should lie between 38 and 65. Now if you were to look for the right choices, 38 and 65, this is the correct choice, and this is the correct choice, and this is the correct choice. So the only thing which cannot be featured as a correct choice is this B, but they are asking for that value, right? So the choice in this case is B. So that's the solution for this question. Students, let's do this question. Let union I ranging from 1 to 50 of xi be equal to union I ranging from 1 to n of yi is equal to t, where each xi contains 10 elements and each yi contains 6 elements. If each element of the set T is an element of exactly 20 of set xi's and 6 of the sets yi's, then find n, right? Of course, looking at this particular relationship, you would be little bit jolted, but don't worry. Now, solution. I'm going to give the solution in this following fashion. Now, whenever they say like this, I is ranging from 1 to 50 with a capital U of xi, the meaning is I takes the value from 1 to 50 and you are performing the union of all these elements here. When I is equal to 1, you get x1. That is union, or I would say that is performing a union with x2, which in turn is performing a union with x3, which in turn is performing a union with x4, and so on and so forth up until x50. So we are actually taking the union of elements starting from x1 to x50, right? Now it says that each of the xi contains 10 elements. So this has 10 elements, this has 10 elements, this has 10 elements, this has 10 elements, and so on and so forth. This has 10 elements. So if someone were to ask us the number of elements in union I is equal to 1 to 50 of xi, then it would be I is ranging from 1 to 50, so it's going to be 50. Each of the xi's have got 10 elements. So this is going to be the value. Number of elements present in this union is going to be 500, right? Okay, now let's go to union of yi. I is ranging from 1 to n. This is nothing but there is a union performed between y1 and y2 with y3 and so on and so forth with yn. Each element in y has got 6 elements. So there's a 6 elements here, 6 here, 6 here, and so on and so forth. 6. Total number of y's is given to be I is equal to 1 to n. So n multiplied with 6, which is equal to 6 times n. So this is the information that we have got with regard to the number of elements from, or number of elements present in the set 1 followed by number of elements present in this set 2. Right, so having got that out of the way, let's move on to the next statement that is being presented here. If each element of the set is an element of exactly 20 of xi's and 6 of yi's, so what they are trying to tell us is that they are trying to infer a relationship between xi elements and yi elements. and that relationship can be written in this following fashion. So we can have 500 divided by 20 is equal to 600 divided by this is what the relationship gives us. So now what we can do is we can divide 6 with 6, 0 with 0, and 2 divides 25 times. Therefore, the value of n is equal to 25. This is what is required, and we have got that value. So we'll move on to the next question. So students, now we will deal with questions related to cross product, n of a cross b. Now the foremost, that is the point of focus, is the formula. Now what is n of a cross b? N of a cross b is n of a times n of b. This is a very important formula you will have to know. Now having given you this formula, let us do a question. Let Z be the set of integers, and if a is given to be all x element of z such that you got modulus of x negative 3, which has a power of x squared negative 5x positive 6, and that is equal to 1. This is a set for a, and b is equal to all x element of z such that we got 10 less than 3x positive 1 less than 22. We are asked to find the number of subsets of a cross b. This is a lovely question. So foremost, let us write down the set for a. Now we've been given modulus of x negative 3 raised to the power of x squared negative 5x positive 6 is equal to 1. We can rewrite this as modulus of x negative 3. I can factorize this x squared negative 5x positive 6, and that is going to be x negative 2 times x negative 3 is equal to 1. We need to look into this aspect. We need to produce 1 here. How is it possible? Or in other words, what should be the value of x for which upon substitution would produce us a value 1? Now clearly, if I were to take x is equal to 2, this is going to be 2 negative 2, 0, right? And this is raised to the power of 0. Of course you will have 2 negative 3, but that's not going to have any inflection or any impact on the result. The moment you place 2 here, this is going to be 0, and this quantity raised to the power of 0 will give us 1. So x is equal to 2 is one value. The other value is that we can literally make this quantity to be as 1, right? If I were to make this quantity as 1, what would happen? 1 raised to the power of this value, what would we get? It doesn't matter whatever value that x takes here, or this quantity, this expression takes here, is not going to have any impact, because 1 raised to the power of even 1 million will give us 1. So if I were to take x is equal to 4 over here, 4 negative 3 is going to be 1. So that is another possibility. So these are the only two possibilities that will fit in such a manner that this relationship holds good. So we need to have this equation to be true. So subsequently, this would mean the only values that the set A can have is going to be 2, 4. You may be wondering, can I put in 3? No, you cannot put in 3. If you were to substitute 3 here, this will become 0, this will become 0, and 0 over 0 would be undefined. So we cannot have that. So this is the set for A. Now coming back to B, let me use this part of the page. Now I've got B to be as 10 less than 3x positive 1 less than 22. I can subtract 1 throughout. That would mean 9 less than 3x less than 21. I can reduce this by 3 less than x less than 7. So the values of x for set B should lie between 3 and 7. So that's going to be 4, 5 and 6, right? Now we need to obtain n of A cross B. So n of A cross B is what? N of A cross B is equal to n of A multiplied with n of B. This is a formula. So number of elements in A is 2 multiplied with number of elements in B is 3. 2 times 3 is equal to 6. So now we have a cross product. Number of elements in A cross B is equal to 6. Isn't it amazing? Now we are expected to find the number of subsets of A cross B, and therefore the solution is going to be 2 raised to the power of 6. Right? That's the final answer for this particular question. And if they were to give you the choices A, B, C, D, the probable choices would be as follows: 2 raised to the power of 6, 2 raised to the power of 8, 2 raised to the power of 15, 2 raised to the power of 9, and clearly we know that 2 raised to the power of 6 is the right answer. So thank you, students. This completes our entire section on set theory. I hope you enjoyed this, and the best way to go to the top is by practice and more practice. Thank you.